Well, hello everybody and welcome. Sorry about that little 10-minute delay or 15-minute delay. I didn't mean to do that. I had a call come in that I had to take. I apologize for that. Now, as always, I am here with our wonderful friend Darrel. Hi there, Darrel. How's it going?
Hello, Mark. I'm good. You? Hello, everybody.
I'm
Not
fine,
always,
thank you.
Usually.
Yeah, well, tonight's a little bit of a different night. It's getting dark out there, but tonight is a potential meteor storm, so we're going to take advantage of that, and I have a way to do that, which I'm going to show you right now. Okay, this system right here that's coming up, this is actually a AllSky camera that we've got. It's not quite dark enough to use it yet. Because you can just see the edge of the camera field here, and it's a circular field. So there you go. That's what it looks like now. The lens was cleaned off today, happily. But this is something that is good for us because this is an all-sky camera. It's showing us 180 degrees, 360 degrees around, and we're going to get to see the entire sky. Once it gets fully dark, we won't lose a meteor because we will take 25-second exposures. So we're going to see all the beautiful stars and the streaks of all the meteors. So this is probably the best way to record the meteors tonight. Because when it's live, then it comes and it goes. And you say, oh, get the time. But we have a lot more data than that. We're going to have data that tells us the time, the date, and all that, and it's going to be also imprinted on each image. And then we store all the images, and at the end of the night, I'm going to leave this going all night long, and maybe not the stream, but I'm going to leave the camera running all night, and we're going to capture every single second of the entire night in imagery, and then we'll be able to check out what it looks like tomorrow when we put it into one big video. An AVI, yay, and that'll be pretty cool. So that'll be neat. So until it gets dark, obviously, we'll leave this. We'll pull that down, leave it out for a minute, and we have our regular view that we're used to seeing. We have our telescope control. We have the telescope in the building. There it is. And this right here above me, you can't really see it until I actually move the telescope and turn that on. That's our telescope computer. We're peeking in. This is our view, as I said, and here's the camera control system over here. So we're ready. We're poised for the night, and it's going to be really nice. So thank you for joining me. Thank you for coming out. And Bem is in the house. What's up? That's my childhood friend that called me earlier. That's Joe. He's in a vacation right now down in North Carolina. How's it going, Joe? Good to see you. And so we're actually here waiting for it to get darker. It's actually coming along pretty well, going pretty fast. If you go over to our planetarium side and check out the planetarium view, this kind of gives us an idea what's going on. I have the atmosphere turned off for our planetarium view, but if I turn it on, it'll show you how much sky glow is still going on. So this is what it looks like right now out there, pretty much. All right, so what we'll do, just for fun, is the telescope now is currently pointed down here. What we'll do is we're going to go up to Spica. We're just going to have it go up to Spica. Because we're going to be hanging out in that part of the sky most of the night, Yeah, so that's pretty cool. All right, so we're going to go to our maximum slew rate here and head up north with the telescope. So you watch over my head, you can see the telescope going up. There we go. And in our planetarium there, you can see the crosshairs moving up as the telescope goes up. All right. And then we'll move over. It's not quite dark enough to let the telescope computer do all the finding of the waypoint stars, so I'm doing it manually. So as I move over towards Spica, we should see Spica appearing in the view when we pull it close. So first we're gonna center Spica. How's everybody doing, by the way? Let me know in the chat how everything's going on. I'm looking forward to this evening. And you know what? If we're lucky, if it really is a meteor storm, then we'll see what we can do about trying to identify the radiant and so forth, and maybe, if possible, we could, in a very lucky chance, see a meteor come through our field of view. We are 4 full moons across and 3 full moons tall in size, so that's pretty cool. So we might have a lucky opportunity here. So we'll try it. Wouldn't that be cool, Darrel?
That would be beyond cool if we get to see it.
Yeah.
Second coolest thing I ever saw was the Leonid storm back 22 years ago.
Really?
Thousands of meteors an hour. Everywhere you looked, there were meteors constantly.
Yeah. See, that's the thing about the AllSky camera. We won't miss a single one.
Yeah.
We won't see them with your eye, but the camera will pick them all up, and we might see streaks everywhere, all over, and that's what I'm looking forward to. I'd love to see that happen. All right, I'm gonna come over back here just for a minute, and I'm going to increase the brightness of our camera view here to our fundamental size here, and we're gonna see Spica show up in here pretty soon. I'm only at 2 millisecond exposure right now, and that's literally a very short exposure, actually. Donald Kunzer asked, what's the star marked Ver? Well, I think Ver is actually Alpha Virginis. This is the alpha star, the brightest star in Virgo. That's called Spica.
Negative. Mark, his question is that little star directly below Spica, near the edge of the frame, I Virginis.
Oh, okay. If that's what he's talking about. Oh, I see. Anything special about okay, I see the now, yeah. No, stars are sometimes labeled with a letter followed by the 3-letter accepted mnemonic for the constellation. So this is I Virginis, as Darrel just said. Nothing special about the star. You know, hello Izabela. Hi Genghis. Hello PG. PG, I'll see you in a few days. And by the way, hi Donald. Dagger is here. Bonnie Anahata is here. Good to see you guys. Vera Lucia from Brazil is with us today. And Tim is with us. And the Keen tribe. So good to see you guys from Alaska. Holy cow. It won't be dark there for a few months. Yeah, well, actually August, I guess. Oh, it says so. Look, August. Yep. And it's nice to hear from all of you tonight. And we will be checking things out. Michael Klagus, good to see you. Fantasy, of course. You know. And Ufi, how's it going? Ufi Atari, it's good to see you as well. We're going to have a good night tonight. And tomorrow, I will assemble all the images that you can all look at and watch the video of the night with potentially lots of meteors. Or maybe just 1 or 2. You know, that's what they say. We can have a meteor storm or none. Yeah. Yeah, it's worse than the weatherman, let me tell you. Right? And Daisy and Zoe, catch a falling star and put it in your pocket. There you go. That's very cool. Very nice. That's a good thought. Yep. So we're gonna keep moving along here. Let's get going here, and let's go up to Spica like I said we would do. First things first, I'm going to go to just a little bit faster, and now I'm just going to move the telescope a little more to the east here, and you'll see it come across the line there, horizontal line. And there's Spica. Here it is right there. You can see it in our view. It's coming into view. Okay, so right now there's Spica. All right, and so I'm going to center it up. I'll use my crosshairs here. All right, and I will put it in the middle, and then once I get it in the middle, I will make sure the telescope coordinate system is set up and identified properly. So let's go a little east. And we're going to go a little north to bring the telescope pointing up more. A little more east. I feel like I'm controlling, like, you know, the weapons, the doomsday weapons of the world here. The bullseye is on. Okay. Yeah, it's okay. I can lose it a little. Don't worry. All right, so we got that, and now we're just gonna go a little west. Pop that over, and the tiniest bit south, just to get that right more at near the top here. There we go. Okay, and let's see. This puts us dead center. This puts Spica dead center in our view, and our telescope, you can see the coordinate system's off by just a little bit. So I'm gonna adjust that right now. Boom, and now that should move over. There we go. The coordinates have been updated here, and so we are as close as one could be to being correct. So we're good. All right, and we're still waiting for it to get dark.
Mark, can we do something in Stellarium real quick before we start exploring?
Yeah. All right, what would you like to do?
Okay, back out some. We don't need to physically move the telescope. I just wanted to move in Stellarium for a bit.
Okay,
keep backing out. You know, Arcturus, speed on to Spica. Get Arcturus in the field of view.
All right, here it is.
Okay, there's Arcturus right there.
Yeah.
That is the brightest star in the sky right now.
Yep.
And from Mark's point of view, it's a little bit east of the meridian still. When the shower happens, the radiant point that the meteors will appear to come from is a little bit north of Arcturus. If you draw a line from Arcturus to Alcade, the end star in the handle of the Dipper, Big Dipper, it's about 1/3 of the way from Arcturus to Alcade.
All right, let's go let's go do that. Okay, there's Canis Venatici over there. Let me just shut off the selection. We don't need it. There's the Big Dipper's handle over there. And this guy right here is Alcade right there. Here is Arcturus. And right about where I have this field indicator, that's sort of a third of the way, just over a third of the way. It should really be about here.
Yeah.
I'd say. Right about there, maybe.
As we get to later in the evening, Arcturus will... Oh, I looked and I forgot for Mark's location. Arcturus will cross the meridian 11-ish, maybe.
Okay.
Well, no, let's see. Take away an hour for standard time. 10-ish, 10:30-ish. Arcturus will be as high as it'll get due south, and the radiant will be just a little bit north of Arcturus. So if you get a chance to go out and look, just look up in that general direction. The meteors will appear anywhere in the sky, but if you can trace their direction of motion back toward north of Arcturus, you'll know it's a shower meteor.
Yep. And we will look to see if we can do that, because we'll see Arcturus on the AllSky cam. Okay, again, the AllSky, okay, this right here is the zenith. This is the overhead. So for the AllSky camera, our view with the AllSky camera is going to be what I'll show you right now, approximately here. All right, it's going to be, let me get rid of this. All right, get rid of these and just have that one set of lines. This is what our AllSky camera is going to look like to you. All right, we're going to see this. All right, so you'll see Arcturus right here. And we're going to be looking in this region of our AllSky camera. So not up here, not over there, not over there, but just kind of this lower left quadrant here in our AllSky camera. In fact, I think in our case, it's going to be the upper right quadrant because I think the camera south is at the top in our camera. So, but I'll point that out once we get there.
Okay. Izabela, this storm, if it happens, is unique in the sense the comet, which is the parent of the meteor stream, Schwarzmann-Walkman 3, I believe,
Yes.
was discovered back in 1930, and then they lost it again. And then they found it again. In 1995, astronomers saw the comet break up in space. And Hubble and the Spitzer infrared telescope both got really cool pictures of it breaking into many, many pieces. And some scientists or astronomers who study such things, they have been working on the meteor streams from different orbital passes of the parent comet, and they have reason to believe that one or more of the streams is going to pass tonight. Will it be a once-in-a-lifetime thing? Maybe once, I forget how often Schwarzmann-Walkman came through, maybe every 5 or 6 years, I think. So we may see like a storm return every 5 or 6 years.
All right, let's check out. Okay, that's not so bad, but it's a 2 millisecond shot. I like to take pictures in 1 second intervals here. So that's what I like to do. I'm going to do that. So I'll do the 1 second interval here, and then that'll be in there, and I can just hit that enter and do it. All right, there we go. And bring the gain down a little bit on this. As you can see that, oh, that's auto, didn't mean that. Wrong one. It was the wrong one. I need the gain to come down. There we go. I believe this is Bach, isn't it? Yes? Bach? Isn't this Bach?
I don't know. Let me listen.
Okay. That's right, you can't hear it. I didn't share the music with you. It's air.
Oh, air on the G string?
Yeah, I think so. Isn't that Bach?
Yes.
Okay. Well, this is actually by the United States Air Force Orchestra. That's who's playing this one. It's not all flying planes and shooting things down. Okay. Hi, Taryn Marie. How are you? Nice to see you. Well, let's go and see what a 3-second exposure with our AllSky camera gets us now. I have it on 3 seconds. I'll change it. Alright, so we can do more. Alright, so let me go in there. Let's make a change. And let's make it 12 seconds, 12,000 milliseconds. Save changes. And we'll see what we get. And once I start this, I'm gonna keep it going all night long. All right, so waiting to see what this one will look like. Maybe I didn't. Oh, I might not have saved it. Oops. Okay. All right. All right. All right. I got you. I got you. Let's go back into the settings. All right. Go into exposure time. That's 12,000. Save changes. Make sure that I got that right. Exposure time, fixed auto, yes. All right, exposure time. There it is. Milliseconds. Okay. Okay. Now let's do it. Let me do it this way and see what I get. All right, so it's doing a 12-second exposure now. This will tell me what's going on. I may have to just get rid of this for now and do it the other way. Okay. Let's go to preview image. Okay. It's counting up. 7, 8. That was the last one. Okay. Let me look at something. Look at my settings. I get it right. There we go. Ah, that's why. Okay. I wondered why.
I believe on that AllSky view there, the brightest star, highest up, closest to the south, is Spica. That one right there is Arcturus.
Yeah, that's what I was looking at right here.
Yeah, and then I think that's Vega down to the lower right.
Right, and here's Alcade right here. And this is, all right, so here's where we're looking for the meteors tonight. And we'll see streaks in here, okay? This is the Big Dipper. And that's Arcturus. That's Spica down there. That's the black dot. That's a black hole. No, I don't know. All right, so right now, a 12-second exposure is giving us this right now. As soon as we can do and just run with it, we're going to actually start running the system. So when I come back, I'll come over here to run the system, and I'll hit run. And it'll just take continuous exposures all night long. And we'll just come back and look, and we'll go through them and check them out, and then look at the video tomorrow, and it might be pretty cool. And we'll actually, once this gets going, we'll actually come back to this and watch it in particular. All right, so that said, we're still in good shape right now. Yeah, there we go. I can have it do another one while we're waiting. And you notice up here it's counting up. See, it's 5, 6, 7, 8, okay, 9. And the stars, you'll see the stars visually move just a little bit each time. And you see more stars showing up as the sun over here starts to set. This is the west, this is the east, this is the north, and this is the south at top. All right, so here is the North Star right here. That's Polaris. You can tell because you can see the Big Dipper right here and the 3 stars in the handle. Those 2 end stars in the Big Dipper point right there to the North Star, and the North Star, of course, is part of Ursa Minor, and this is the Little Dipper right there.
Yep.
So there's the North Star. So everything is rotating this way around that. It's moving from right to left in a circular around this. Go ahead, Darrel. I'm sorry.
Oh, well, the two stars at the front of the bowl of the Big Dipper, Dubhe and Merak, they're the pointers that point toward Polaris, the North Star.
Yeah. I could always change this. So let me have it run. Okay. And so now it's running. So everything that's going to happen in the sky tonight, we're going to see now. One exposure after another. We'll see planes, we'll see meteors, we'll see satellites. We're going to see all kinds of things. And that's kind of cool because the sky's going to get dimmer and dimmer and dimmer and dimmer. Yeah. All right. Meanwhile, let's go back over to our other system here. And over here, this is Spica with its attendant stars around it that we see right here. All right. And let's go over. Let's come over here and let me bring up the objects that might be fun to look at tonight. There's so many of them right around us this time. Virgo is one of the most populous constellations, along with Leo and Coma Berenices. Okay, Coma Berenices, I'm not sure. I'm not sure how to say that, to be honest.
Greeks would have said Berenike.
Berenike?
Yep. C was a K sound back then. Kind of like, Celtics versus Celtics.
Yeah.
But nowadays they would say it's Berenice's hair, so say Berenice instead.
Yeah.
There's that blow dryer.
Yeah. I was looking at the blow dryer thinking, are we going to look at the blow dryer? I mean, it's a good test to see just how dark it is, So why don't we check it out and see just how dark it is. And if it's dark enough, well, we'll be good. So I'm going to tell it to go there now. And you'll watch the stars slip away here, and you'll watch the telescope move. There it goes. Don't be fooled by the brightness on the screen. We have a very sensitive camera. And we're going to be using this star as a waypoint star. And what star is that? Let's find out. Okay, Nebula. Nebula, the tail of the lion.
Yep.
And then after we get Nebula centered, the Blowdryer Galaxy will end up right in there. I'm going to give us our fully enhanced image here. Here it is. Well, it's dark enough to see the Blowdryer Galaxy anyway. How about that? It's not bad. Of course, right now our gain is at 153, so our gain is low. And we're only taking a 1 second exposure. I usually take images at just over 250 or so. I rarely go above that because then I get grain, and I don't want too much grain, but we'll do a 253 right now, and we'll see what we can get with a 25-second shot. Yeah. All right, so it's underway, and we'll stack it and get rid of our live view here. So it's going to get dark here for a minute. Yeah. We'll clear this. There we go. Yeah, see the you can see the color of the sky still. We can correct for that by actually doing a color correction, and then move our dark level in a little, as you can see, and then slide our mid level down to actually kind of lose some of that grain and give us a little better view while we're waiting. Don't forget, meanwhile, in the background, we got the meteors to watch for. So this is the view from just 10 seconds ago. All right, so it's a time exposure, and meteors will show up as streaks, and satellites will show up as lines, basically. All right, so this is good. Let me try something. Let's go to 05. Yeah, that's not that good. Go to 15. All right. All right, and let's try 017. All right, a little bit more contrast. That's good. You can see we still have sunset out there, but we got lots of stars already. Not bad, not bad. We can zoom in a little. There we go. Meanwhile, we're stacking the Blowdryer Galaxy, Darrel, and it's behind here, right here. There we go. We're doing multiple things tonight, but it's good because we have this potential meteor storm. I really hope it becomes something cool. Hello there, Parker Owens. How are you? Yeah, you're absolutely right. Parker says, are we going to have to wait? Yes, we are. We're going to have to wait till we see what kind of numbers we're getting. You're absolutely right. Thank you, Vera. That's very kind of you. Thank you so much. Once we get an idea, Parker, we will know. We will know immediately whether it's going to be a good night or not. Because if we start to see some, that'll be a good indicator that they're going to continue. I've never seen a meteor storm in my life. I would really like to see one. Darrel has. I haven't.
Yeah. When you the big year for the Leonids, 2000, I guess, 2001, whatever. As I said earlier, you look anywhere in the sky and you saw meteors constantly. But if you faced into the radiant, the radiant is inside the sickle of Leo, that backward question mark. Regulus rises right at midnight here on November 17th, the night of the Leonids. And by about 2 to 3 in the morning, Leo, the head of Leo, was getting up there fairly high in the east, and looking into the radiant point, it was just like being on the Starship Enterprise on the bridge when they're flying at warp speed, and you see the stars streaming out constantly. That's just cool. What it looked like. It was amazing.
Wow. Telescope is held focus from one night ago. I haven't even focused it, and it looks like it's pretty good right now. Can you believe it? That's pretty good. Usually you have to focus, but that means that the telescope temperature stayed relatively constant since throughout the day, so it hasn't changed much. Hey, John. I saw a huge red meteorite in New York City about 1 hour ago. Wow. Red meteorite, huh? You know, here I am inside the house in Connecticut. You know, I should be looking outside, right? And Darrel's going to excuse himself a couple times to go look outside.
Yeah.
Cindy Murphy, hi there. And I got Just Doomsday, that's cool. Charity Rose Walker, Central Florida, nice, good to see you. Thank you for coming along. And this is our AllSky cam that we're viewing right now. And we're taking 12-second exposures so we can actually see more detail. I'm gonna up that, and by the time I'm done, we're running all night with this camera, so these are gonna be available to you up at our server to look at individual frames. Yeah, Jono says he's been seeing them. Hello there, old P. How you doing? Palooza, what's going on? Yeah, I'd love to see them appear everywhere in the sky. Darrel, I think that would be pretty cool. Palooza is in Central Florida as well. We got people from all over. Hey, Kathy, how are you? Good to see you. Blabrana, hola from Scotland. If you look at our AllSky, you notice that we actually see a lot more stars now. I'm going to up the exposure slightly, but I've got to actually turn the system off for a minute to do that. So I'll quickly go and change the application settings. I'm at 12 seconds now. I'm going to go to 15 seconds, and it will be brighter. Sorry for those of you looking at this on a big screen. This is a little bit of a problem for you, I know, because it just blew your eyes out. I'm sorry. All right.
We have 135 attendees right now.
Fantastic. Well, thank you for coming in, guys. We're going to run this again. Go back to our preview. We're doing two things tonight, guys. We're watching the sky as well with our AllSky camera, looking for the meteors. And at the same time, we're actually imaging galaxies. All right, this galaxy right here, this is a live image that we just took. In fact, it's still going right now. Just another exposure is about to be added to it. There it is.
Marianne is here.
Marianne, hello, Marianne. Marianne is our project treasurer. She is with SkyTour Livestream. Marianne is one of the movers and shakers of the SkyTour Livestream project that we are part of. So for those who don't know what they're looking at right now, let me just tell you, this up here, you can see right here, this right here, this is the telescope control cluster right here, where this is controlling the telescope. That's the telescope right there in the building out in Arizona, okay? And this over here, this right here, this along the bottom, this is the data from the telescope. We're actually stacking images, just making a sandwich of images. And then this is the camera control system over here. All this data is how we control the camera. All right. We have a pretty elaborate system out there. We have a system which can find the best focus to a very, very precise degree. So we have a lot of fun with this. We've done a lot with this. Is Tara here too? Did I see Tara is here? And Ronald is here. How you doing, Earth Radio? Christina's Garden, nice to see you. Christina's Garden, she said she watched the 2001 Leonids as well. It was an amazing. Yeah, the Leonids are extremely beautiful. They're in November. And OG Skywatch, good to see you. Oh, Terra Furnace, how you doing? Nice to see you. This is the galaxy, yeah. And we're doing, as I said, multiple images, multiple things. Okay, this is our live view of the AllSky cam. It's actually a 12-second exposure and a 15-second exposure now. You can see many more stars. This telescope that we're running is actually out in the Arizona desert, and I'm in Connecticut. Darrel's in Colorado, but I'm running this out in the desert, and that's it in the building right there. And so what you're going to look for here on the AllSky camera is you're going to look for streaks, and these will be meteors. Now, I've got this running, okay, so this is running all night long. It's going to capture everything that happens. Every single thing that happens, it's going to capture it. Whether it's a plane, whether it's a meteor, we're going to see it. Even after we go to bed and shut down, this camera's going to keep going. And it's going to go until 6 in the morning, at which point it will shut up and go put itself to bed. And that's good. James Dugan's here from Australia. Good to see you, James. And Mammy is here. When will it go live? Also, in what direction to... Okay, let me show you what direction to look. If you look right here, do you recognize this? This is the Big Dipper in our AllSky camera. There's the bowl of the Big Dipper. These are the 2 pointer stars, which point to the North Star right here. Okay. This is the tail. This star here is Alkaid, and this star here is Arcturus. And right about here is the radiant, where they will seemingly appear to come from. So technically they should be streaking this way, okay, coming from there and heading in all directions. But you know what? Meteors are funny things. They may or may not do that. I don't know. But I hope we get an amazing storm tonight of meteors, because that would be really pretty. You know?
Mark, check your chat, please.
Okay.
Yeah, if you see the AllSky camera there, folks, if you draw a line from that bright star Arcturus, which is a little to the upper right of center, down to the end star of the handle of the Big Dipper, the radiant is on that line a little bit to the lower right of Arcturus.
Lower left, you mean?
Lower left, I'm sorry.
So it's right about there.
Yeah, the meteors will appear anywhere in the sky, but if you can trace their direction of motion back toward that point to the lower left of Arcturus, you know that it's a shower meteor.
Yep. Now, at the same time we're watching for the meteors on our AllSky cam exposures, we are also, we're not shirking our duties, we're actually capturing galaxies. We have 30 stacked images here, and we'll do one last little process here. Let's process this a little bit. All right, and when we process this, this will give us a better color, and then what we can do is bring this like that. And this is a little bit too red, and I'm going to drop the red out a little bit. Bring this down. That's a little better.
This galaxy is known as Messier 100.
It is colloquially known as the Blowdryer Galaxy, which I think is kind of interesting because it doesn't look like a blow dryer to me. Does it look like that to you?
That sounds like another one of those stellarium names to me.
Doesn't it though?
I mean, we'll probably see the Lawnmower Galaxy next, knowing them.
Right. But hey, you know, this is what we're looking at. We are looking at what is known as Messier 100, and it is a really nice galaxy. It's one of the prettiest, actually.
It is.
All right, let's bring that out of there so we can see our tags there. I'll bring it back up just to try another color correction here. We're going to color correct that. All right, there we go. That's pretty. Blowdryer Galaxy. And we can actually full screen that too, so you can just see, like, let's pull it in. There we go. Yeah, make sure you give us thumbs up, guys. Hey there, Ronald. Ryan DeBoer is here. You can drive up into the foothills in Southern California. That's good. It'll be pretty. Yeah, hey there, Roni. Yeah, it's really pretty. Hey, I figure, you know, if we're looking for meteors, we might as well, we're not going to miss anything. We might as well look at galaxies, too. Notice these spiral arms. They're just beautiful. you know. And I often think, how many living beings are we actually looking at right now? And you know I say that a lot, but it's true, right? How many living beings are we looking at? We might be looking at billions.
Trillions.
Maybe, yeah. Hi, Charity Rose again, and Jessica S. I think that this is pretty good. Now I want to push that back so I can see my telescope again. And what I'm going to do now is check out our AllSky once again. All right. I don't see meteors yet, but you know what? These are think of these as frames. These are actually frames. Get over there. These are oh, look at that. Look at this right here.
Whoop, caught something.
Look at that. That may be. That may not. Yeah, we have to wait. Okay. It was there again. So that might actually be a plane. Because it was another. It was there 12 seconds or 15 seconds later. But we'll keep watching.
Ronald, I saw a star chart, a sky chart a few days ago on
Maybe not.
space weather, if I remember right. And they said actually the ideal place to be watching for them is down in Baja, California, southwest of Marc. The radiant point will be directly overhead there, and dark skies and all that good stuff. And so actually even
too.
farther south of Marc might be the best place.
Yeah. So you see,
It's
we
worth
already
looking wherever you have a clear sky.
I like that we caught something already.
Uh-huh.
That was interesting. There's another one. That might be a satellite, but we have to wait and see. The next exposure, if it's, yeah, see, if it moves, it's a satellite moving through the field. Yes, that's a satellite. Can you tell, guys? Because it's a 15-second exposure, and you see it moving across. Right, every 15 seconds. I mean, this is really cool stuff. Again, here is the Big Dipper. There's the tail of the Big Dipper right there, and here is the bowl of the Big Dipper. See that? And these two stars point to the North Star right here, and now you can see the whole Little Dipper right there. And in between this star, the N star, there's another one right there, the N star and Arcturus, right about here. This is the radiant for the meteor shower when we start to see it. Okay. So these might be Starlink satellites that we're looking at here. No, actually, I'm not sure about that because this one actually is broken up. So this may be. Oh, look at that!
Got another one right there. Yeah, you just.
I think we just had a meteor. We just had a meteor that was caught there, so we got one, and that was probably at the radiant. That was probably one of these Herculids.
Yeah.
So we caught one. Look at that already. And these are. This looks like an aircraft to me, but it doesn't. I mean, this could actually be a. It's moving too slow. That looks like could be a tumbling satellite. Okay, this is definitely a satellite here. So you see how this is working now? This is how it's happening. We're catching these in these spurts. Some of these, because we're doing time exposures, some of these won't be visible to your eye, but you see them on here instead. This is where you'll see them, as opposed to by eye. And again, Arcturus is here, and the tail of the N star, Alcade here, and the Big Dipper. Here's the Big Dipper. Draw a line between these two, and right about there is where we should see radiant. We should see things coming out in these directions.
You know, that
Right.
one that was just above Arcturus, you caught a few
Yeah,
frames back, might well have been one.
Yeah. I know.
It was-
That's what I said.
Yeah,
I
it was
thinking.
pointed the right direction for the radiant.
Yeah.
I'm going to go out and take a look real quick. I'll be right back, Mark. Excuse me a moment, please.
Yeah, sure. Go right ahead.
Be right back.
All right. Okay, let's come in here. I'm going to go back to my image of the galaxy here, and I'm going to stop the photography on the galaxy. I'll say pause. All right, and I will name this as M100. All right, galaxy, and we will save it. And it's going to save this galaxy in a FITS file format. This is the astronomical format. And then we're going to save it exactly as seen, so that what happens now, in just seconds from now, every image we take is leaving the building out in Arizona desert and heading up to the cloud. So they'll all be available to you on the cloud within seconds. All right. And usually Izabela will put up the link. Hey, Kimberly Ann, how are you? I do exposures the entire time for this AllSky, yes. And the reason is because, you know, from the point of view of trying to capture anything, it allows us to capture objects in the sky far, far better and far easier when we can do a time exposure. We're not losing any of them. We're capturing them all. We're capturing all of it. You know? Yes, please do the thumbs up thing if you haven't. And if you think it's going to block something, not to worry. This image is actually pristine and preserved. And then tomorrow I'm going to put this all into an AVI, and you can watch them. You can watch the entire night from, because I started this, it's running. The program is running. You can see this green bar. So each image is saved in a location, and then it's being shipped out up to the cloud. Yes, at 2 o'clock, that's a house on the property. The observatory is on a protected piece of land. That looks like the Zodiacal Light to me. It's not light pollution. There is none. But interesting. I remember when I saw the Zodiacal Light, which is the backlit light of dust in our solar system that may very well have come from Mars, from large impacts on Mars. When I first saw the Zodiacal Light, I was thinking, oh man, light pollution out here? This is why I picked this site. No light pollution at all. But then it was weird, because it was going on a weird angle. And I figured, man, that's not... And I was like, oh my gosh, that's the elusive Zodiacal Light. You don't see it unless it's really dark. And we're capturing it in a 15-second exposure. So it's not bad. Yeah, 15 seconds is doing well, guys. This is pretty good. These lights here, this is east. This is the lights of Phoenix. It's literally close to 70 miles away. All right, you don't see those with your eye, but you see them. You see them with the sensitive cameras that we use. Okay, so that's how that works. Hey there, Pocono Joe. How's it going? Yeah, Leonids can be really fast. They can really mount up quickly. So whereas each of these images are static, what it does for us in the end is that we capture everything. So you'll see the streak, and then you can actually reference the exact frame and see the exact singular frame where this occurred, and you won't lose it. It won't be it won't go away. And in spite of how blurry I get, you don't have to worry about it. So this is neat. Yeah, this is looking good tonight. I'm really happy with this. Oh, there we go. Look at that. Let's see what that is. If that's a satellite or meteor. If it shows up here in the next frame, then it's a satellite. If it's gone, then it was probably one of these meteors. Okay, that's a satellite. most likely a Starlink satellite. We did catch one meteor a little while ago right here. That was very nice. Yeah. Okay, I am going to make a slight adjustment. I'm going to, let's apply this. Let's see if this helps us. That's a little too much. Let's do this. Point. Oh, hi, Darrel.
Hey.
5.
Seen anything else?
We had a satellite come through, but nothing yet. I think I'm catching the Zodiacal Light here. It looks like Zodiacal Light anyway.
That could well be.
Yeah. And when you zoom out, okay, you can see this. It's at the correct angle. We should see it twice a year, and I think around now is one of those times we see it. Hello there, Elder Nunez.
We may be toward the tail end of seeing it in the springtime.
Yeah.
Usually March is good. March, April. Sure looks like it though, doesn't it?
Yeah.
I just took a quick look outside here. My eyes weren't dark adapted or anything, so I didn't really see anything. It is nice and clear here now, though. Beautiful night.
That's good. That's good.
And it's getting cold outside too.
Yeah. All right, let's go over to our. Quickly go here back to our galaxy, and I'm going to quickly go back to our 1 second exposures and maximize that, and drop down to our. Oh, I gotta get rid of the stack too, which I'll do in just a sec. All right. All right. Stack I will get rid of. I saved it earlier. Okay. This is what I call our finder view or enhanced view. Love to see a meteor come through the view. That would be kind of cool. Well, bring it up again. We'll vote on it. All right. Let's see now. There's Arcturus. Actually, it'd be kind of fun. Maybe we should just hang out at the Radiant for a while. The chances of seeing anything are slim, but you know what? Why not, right?
Via the telescope, you mean?
Yeah.
Oh, sure.
Okay. Well, the telescope is heading there. You'll see the telescope's moving right there over my head. Okay. Stars get all streaky, and we're going to go to this star here. But first, it's going to take us to a waypoint star, which might be Arcturus. And let's see if it's going to go to Arcturus as the waypoint. There's the telescope where it's pointing. Yeah.
Is that southeast of Arcturus?
Yes, I think so.
Okay.
All right, so here's Arcturus. We're doing one. The halos are an artifact of the imaging system for bright stars, but they'll be gone. Hey there, JSCO 77. Yeah. All right. And now we're going to go to that one little star we saw. There it is. All right, and we'll hang out here and see what we get. Okay, what I should do is I should actually
Don't forget your sky cam is south facing up. You might want to go the other way from Arcturus. If you're southeast
yeah,
up, southeast from it there on the telescope.
let's take a look. I think I went the wrong way. Oh yes, I did, because it's upside down.
Yeah.
Yeah. Good reminder. I really belong over here. Uh-huh. Actually, you know what? We'll do this like we did last time. Let's go check out Mizar. Alright. And get out of there. We'll check out Mizar again, because Mizar was really cool to look at. And when we're in the neighborhood, we'll come back. I like having things to do. So, alright. So, telescope's going to go to Mizar. Meanwhile, while it's going to Mizar, we're going to check out our AllSky cam. And when I come back, Mizar will be in the view. Here in the East Coast, it's 15 minutes after midnight. Yeah, look at that. That might be a satellite, or it might be a meteor. We have to wait and see what the next image looks like. If it shows over here or over there, it's a satellite. If it's gone, okay, it's a satellite. We're going to see lots of Starlink satellites. We actually have Starlink out there, actually, and we're soon going to get it hooked into the observatory building. Okay. Yeah, that's Zodiacal Light. Look at that.
Yep.
Okay. So let's go back and see if Mizar is in the view. I'm going to guess it is. Right dead center. Look at that. So this is that middle star in the Big Dipper's handle. Right? And we'll just center it up so you can see what it looks like. Here we go. That's Mizar and Alcor. And I want to kind of get our telescope alignment proper. There we go. That's neat. Mizar and Alcor are double stars. They're double stars. And they're really pretty to see. And this is just a 1 second live exposure. We're actually seeing it that way. If I don't enhance it, they'll look like this. Much like you'd see them in the telescope. So really pretty. Very nice. Okay. One thing I'm going to do is I'm going to take the focus and mess it up. Because I have not done critical focus tonight. I'm going to. So now, what I'm going to do is go into Tools here. I didn't want to do that. That was wrong. Stop. So Tools, and go into a Focus Assistant. And now we're going to do what's called full width, half maximum focusing. And now what I'm going to do is, might not have enough stars to do it actually. Yeah, we don't have, maybe, hang on, I gotta figure this out.
Jeannie Kilburn, whereabouts in Colorado are you? I'm in Colorado.
Hey Gene, how are you?
I'm in Colorado Springs.
You're in the Springs. Okay, let's go back to our AllSky while we're waiting for this to work.
Tim Horn predicted peak is 1 a.m. in Eastern time zone.
That's in about 40 minutes. It's nice to see you all out here. We've got a little over 400 of you watching right now. That's wonderful. This is our AllSky cam. The nice thing about the AllSky cam, I mentioned this before, is that every single second is preserved. So, you know, when you see something live, it's there and it's gone. You got to remember what time it was and go there and look. Every frame is going to have this data on it. You're going to be able to see it all and check it out. If you haven't subscribed to SkyTour Livestream, please do, because while doing events like this, we're also taking astronomical photos, like right now. Okay, this is a live view of Mizar, and we're using it to do focusing, and we are ready to now do critical focus. Okay, it looks like it found its location, its best focal point, best focus, and it's gonna go out of focus and then into focus on the best point, and then we'll be perfectly focused. All right, and then we can get rid of this. We'll do a 10 seconds on Mizar here. 10 seconds, and we'll stack it. Why not? Just to see what we get. I'll clear the previous stack. Stacks are just image after image after image stacked on top of each other to improve the signal to the noise ratio. Alright, well there's Mizar right off the bat with our first 10-second shot. And let's go in here and correct that. Okay. And now let's do this. Alright, these halos we can get rid of, not to worry. Alright, meanwhile, while that's stacking up... Oh, there's another. Did you see that? I don't know if you saw that. Let's go back for a second. Okay. Let's go back. Check it out. Right there. An anomalous object. This is looks like a tumbling satellite. It looks like a bunch of dashes. So you get a bright spot, then it rotates a little, and it gets dark, and then it rotates again. You see it bright again. So as it rotates, you actually end up seeing this bright set of dots, these lines. That is a what we call a tumbler, a classic tumbler. See that? Not a meteor, but a tumbler. It's good that this is caught in this exposure. These are kind of cool. Neat. All right, so let's go back to our AllSky, see what we got. I'm gonna zoom in one level. Oh, right there. Is that a plane or a satellite? We'll find out. Okay. Might be a satellite. Yeah. Planes have bright hot spots for the strobes and stuff, and I don't see that here.
Yeah. And moving west to east, could be a satellite.
Yeah. Hey Brian, how you doing? Oh, thanks for subscribing. That's very cool. Yeah, if you haven't subscribed, guys, do it, man. We just have so much fun. You know, my name's Marc D'Antonio. I am an astronomer. This is what we look like. And Darrel Mason is with me. He's the guy you hear with me. And he is an astronomer out in Colorado. He's what we call a visual astronomer. You know, I went to school to learn about the actual science of astronomy. Darrel took a different path and went down a path where he learned about the night sky and the objects in the sky, and he can relate them very well. And so Together we make, I guess, one whole well-rounded astronomical information desk.
Hello, everybody.
Yeah. Yeah, that's Darrel. Hey there, Anointing Oil Dynamics. How you? Yeah, Anointing Oil Dynamics. Watching from Trinidad in the Caribbean. Trinidad. I know where that is. I was in Barbados, actually. This looks like a bright satellite. I wonder if this might be the ISS. I'd have to look at the passes and see. Neato. Wow.
Pretty bright.
Yeah, that usually indicates it's probably the ISS. See, now it's starting to fade, as expected. And then this next line, if it's here at all, it's going to be really, really faint. So watch. You can see how faint. Okay, see?
Yeah,
it's just gone. It's gone now. So it faded out. I think it was the ISS. It's only a 15-second shot, so... But it is a very sensitive camera, so... Boy, this is a really nice night out here. Actually, there's now information for the temperature that is available to me now out there. And we'll come back to this in a second. It's 24.25 degrees Celsius out there. Okay. I'm gonna pause this. I won't keep it. We're gonna move to something else. I'm gonna move now to the Radiant. It's about time to go to the Radiant.
Punky, there's one sure way you won't see anything, and that's not to go look. Nobody knows.
Hey there, life is fun. How's it going? Another Bonnie's here. Suri Madrigal, how are you? What time in Mountain Time? Okay, Mountain Time is going to be, for us,
11 o'clock.
Now we're talking, it's 3 hours from here, I think.
What's predicted peak?
Well, the predicted peak is in a half hour.
Yeah.
For me.
11 o'clock Mountain
Yeah.
Time.
Yeah. Okay. Nice. Punky. I hope you see some meteors.
You know what you ought to look at while you're in the neighborhood here before you move on?
You mean the Whirlpool?
Yeah, M101.
Yeah, the Pinwheel.
Very close to it. And the Whirlpool, of course.
Look at that. We got a little object here. This may be a satellite. Doesn't look like a typical meteor. Meteors actually have a bright trail partially through their exposure, where they actually flare, they actually burn up, and they actually make a gigantic flare, then they fade out. This is actually a satellite right here. So the next frame, you'll see another piece of it here, maybe. Yeah. Well, I don't see it there, so that's interesting.
Yeah, the meteors tonight were predicted to be fairly slow moving, and they thought they'd be pretty bright.
Yeah.
But who knows?
But either way, guys, for a 15-second exposure like we're doing, that would pretty much capture the entire extent of the meteor, for sure. You're not going to have a meteor that's going to be more than 15 seconds in the sky. That's very, very rare. I saw one of those in my life, and that was horizon to horizon, a meteor that actually skirted the Earth and went back off into space. We call those Earth grazers.
Linda Rocco, constellation Boötes is just right of center, pretty much.
This is the star Arcturus in Boötes, and this is the tail of the Big Dipper right here. Okay, and the handle, so to speak, and then this is the bowl of the Big Dipper, These stars point down to the North Star. Here's the Little Dipper right here. You can see the square end there, and there's the Little Dipper. So this is Ursa Minor, the Little Bear. This is Ursa Major, the Big Bear. And the handle of the Big Dipper points right down to Arcturus. And for this particular meteor view, the actual place where the meteors look like they're originating from, which is based on how they're entering our Earth's atmosphere as it hits the Earth's atmosphere, is right about here in our physical sky, right? So we're going to be looking for, but that means where they originate from. The street could be way down here and go that way, or way down here and go this way, over here, over there. It can go every which way, because meteors are about 90 miles up, so they could be anywhere along those lines. They could literally fit the entire sky, and this is a full 360 degree camera that's looking at the night sky. We're not going to miss a thing. And the parts that are a little clipped here or there are only because I've zoomed in. If we zoom out, then you could, then you'll see the entire sequence. But I want you to be able to see it better. So that's why I'm zooming in a little bit. When I actually put this into a video and show you every single stream moment from beginning to end, then you'll see very clearly, you'll see the meteors when they show up. And long after we've all gone to bed, this will just keep running, because I'm going to keep running it. I could actually put the telescope away and shut the roof and keep running the AllSky, which is probably what I'll do. And then it'll go all night long. We could just keep watching the AllSky cam. Hey, Deepquake 9, what's going on? Dal Mac, how are you doing? Will you be streaming the bigger meteor shower next week? I guess they say it should be visible to the naked eye. Well, meteors in general are, the peak of this meteor shower is going to be in about a half hour, 1 a.m. or so Eastern time. So it's already started, perhaps. And here's the thing, okay? Nobody knows for sure how the meteor shower is going to look, But we'll see what happens, Hey, Bobby Thompson, what's up? Peace. And ECC. And Hector Antonio Gonzalez Flores, how are you? Nice to see you. And Brax Tax the Plug, what's going on? This is actually, you're out just outside Surprise. Yeah, we're actually out in the Sonoran Desert, west of Phoenix, about 68 miles. It's a 15-mile ride on a dirt road. It's a lot of fun to go there. No, it's not a washout, gray guy. We got beautiful stars. And we're also, at the same time, taking imagery of things. So this is Mizar and Alcor and the Big Dipper's handle right now. And what did you want to look at, Darrel?
Just look up. I'm sorry. Say again.
M101, right?
Sure. We're in the neighborhood, right next to it now.
Yeah. Okay. So we're gonna look for M101, guys. This is the telescope that we're gonna use now. The AllSky camera is doing its own thing, and we're not gonna miss anything because it's capturing all those images. Nothing gets lost. So we'll capture it. We'll see it.
M. Fernandez, just look up. Meteors will appear anywhere in the sky. If you can trace them back to a little north of Arcturus, that's the radiant point. You'll know that they're a shower of meteors. But the meteors themselves will appear anywhere in the sky.
And I will show you where that is in a minute. Okay, let's go now to M101. And you'll see the telescope's moving now a little bit. Not too much because it's right nearby. Okay, let's go look at our AllSky cam. See what we got going on there. Come back. Okay. Okay, so here's the Big Dipper. Yep.
Just a moment. I'll be right back.
Okay, here's the Big Dipper's bowl right there. Here's the handle of the Big Dipper. And the handle of the Big Dipper points right down to Arcturus, which is the brightest star in the constellation Boötes. All right. And it's in between these two stars, the end star called Alkaid in the Big Dipper and Arcturus. This is the point from which these will look like they're coming from, radiating from. What it means is they'll be like on a line to this point right here. So they could be right here. It could be a streak right here. It could be a streak right there, a streak right here, or right there. I mean, anywhere. But the radiant, the point they'll seem to be coming from, is right about here, and that's what's important for the meteor showers. All right, and we're just having a good time. It's a lot of fun, and I'm very happy that you guys have chosen to join us tonight and come out with us. There's almost 900 of you watching right now, and make sure you subscribe and hit the bell. Hang out with us. Hey there, Whitestone God, how you doing? You're on the West Coast. Walk outside and watch. We've had a few meteors actually already, and you know, here's the thing: most times the meteors don't show up until around midnight or so, because then the Earth is rotated into a path where they're going to be you know, coming toward us and striking the Earth a lot better, more obviously, and that's something that's not happened out here in the West yet, because out here in the desert it's only 9:37. For me, it's almost 1 a.m. It's actually 12:37 a.m. here. All right, and John Wesley, how you doing? John Wesley Karhanovich is in Abbotsford, British Columbia, Canada. All right, very good. Yeah, so for everybody, the maximum point, the maximum volume of meteors should happen within the next 20 minutes or so, and thereafter. Okay, so it's not just like at 1 a.m. boom, they start. At 1 a.m. is when they should start reaching their peak, if it's going to happen. Now, you didn't hear Darrel talk about it before. He's back now. I think I just heard him, but yeah. But when this comet that broke apart, that created this meteor stream, was noticed or seen and recovered again, it's possible that the stream is a bust. It's possible that the stream will be a storm. We don't know. Keep in mind that none of us know. We're just providing the stream. And remember, at the same time, we're also imaging the deep sky, because SkyTour Livestream is a deep sky imaging observatory, and this is just a special event. So right now, what we have in here, this is Measure 101. I had the telescope go look at it, and I told it to go there because the telescope knows where everything is. So what we're going to do now is we're going to just set this to do a 35-second exposure. All right. And there we go. We're starting a 35-second exposure. We're going to reduce our enhanced view, or we're going to start a live stack. Okay, now the way stacking works is we take an image, take a second image, align it, and then just keep adding images on and stacking and stacking. That makes the dim stuff brighter, and it actually makes the imagery far cleaner. You don't have a lot of noise. When the first image here comes in, you're going to see lots of noise in this image, you know. But first, we're going to check this first. Okay, nothing yet. All right. Let's get going. Hey there, C&D boy. Good to see you. Okay, so let's go back now. Yeah, look at that. Oh wow, Darrel, look at that. Okay, this is Measure 101. It's the Spiral Galaxy here. Let's correct the color and correct this size here. This is, look at that. These are live, by the way, guys. This is live. This is what you get here. No one's doing this. We're showing you galaxies live, and when the summertime rolls around, you're going to see nebulae and beautiful star-forming regions. When winter was here, we saw the Orion Nebula, the Horsehead Nebula, and many other nebulae. Tens and tens and tens of additional nebulae that we looked at and spent a lot of time looking at. So right now, this is gorgeous. Wow. This is really pretty, you know?
It's like beautiful galaxy.
It is.
It's a big one, too.
It is. It is. And this music is perfect for it. Now I'm popping back and forth between our AllSky system as well, so that we can check for meteors as well, because that's what we're doing. We're here looking at the meteor showers as well. And once again, if you're here and it's the first time, you know, please subscribe and hang out with us. We have over 1,000 people right now watching, and I would really love to have you subscribe and hang with us. You know, and everything we do is free. Every single thing we do is free. We do not charge for what we do. You know, and that's the best thing, I think. As an astronomer, you know, that's what I went to school for. The night sky is my cathedral, and I absolutely love sharing it with you. And if you guys are interested, you know, you can check me out on all kinds of. There's all kinds of shows that I do on all the different networks and stuff. As an astronomer and as a UFO guy who talks about the real science behind potential UFOs. That's another hot button for me, because I think extraterrestrial life is in this image that we're looking at. It is most certainly in this image right here that we're seeing. I believe it's here in this image as well. We're going to zoom in on this now. We've actually stacked 6 images. Look at that. Look at those spiral arms.
Yeah.
Can you believe it? Live image, guys. A live image from deep space right there. This is cool stuff.
Realistic. The galaxy's official name is Messier 101. It's often called the Pinwheel. Pinwheel Galaxy. It's a large spiral, is what it is. Spiral
it
galaxy.
Is, and it looks like it is a galaxy that's just beautiful. And you know, there's different designations for galaxies when we look at them. Okay, among the designations, you know, we have S for spiral, and sometimes they have these extended bars through the middle, and we call those barred spirals. It's an extended nucleus, and then the spiral arms come off of that. We may look at a barred spiral also later on tonight. But there's thousands of galaxies over our heads in the sky right now in our gorgeous sky cathedral. And I'm telling you, we're going to enjoy it. And we have this meteor shower, so I have my other system in the observatory active right now. The AllSky cam is out there to help us locate any potential meteors. And just so you know, for those that might just be arriving, we're taking images every 15 seconds, okay? But you have to understand that even when I go back to looking at, say, this right here, okay, looking at our beautiful Measure 101 galaxy, we're not losing anything. We're not missing anything. You're not going to miss a thing. And the reason is because these images are being captured and shipped up to the cloud. Every single frame, every 15-second frame is shipped up to the cloud where you can go find it and you can go see it. And I will show you that a little bit later. This gives us the opportunity to actually go through this image frame by frame, 15 seconds at a time, all night long, and find every single meteor that occurred and identify them. Identify, hey, where they come from, You know, are these true meteors that belong to this meteor shower? Or are these meteors that are perhaps with just a typical nightly meteor that we might see? But in any case, what we're finding... Oh, thanks, David Coda. Thank you so much. Respect to you too, my friend. Thank you for coming. So we spend an awful lot of time exploring the night sky. This observatory that we built out here, you can actually see on our server, you can find pictures that we put up there. There's one directory showing pictures of the building of that observatory. That's Sky Tour West. Sky Tour Livestream West is out in the Arizona desert. Sky Tour Livestream East is here in Connecticut, where I am. And we actually sold the actual dome that we had. We had a dome, which shows up on our logo, which you can see on the screen. Maybe I think I took it off because it shows up as in a watermark. But we sold the dome because we outgrew it, you know. And I got sick and tired of trying to put things in the corners. That's a joke. It's a dome joke. I sold that dome, and we're building another building out here. Thanks, Vera. Vera is from Brazil, and she is amazing. She's here for every stream. One of our amazing, wonderful regulars out here. You know, hey, Ian here. Ian's from Tucson. Yeah, we're actually the observatory is a little bit north of you, actually north and west of Phoenix, and but I'm in Connecticut, running it from here. So that's cool. This is nice. Now, I said before, the lights of Phoenix show here on the camera. That's the east side here. This is the west side, and this little faint haze here. This is the remains right here. This is the remains of the Zodiacal Light, which is the backlit dust in our solar system. And that's really cool because it's not often you get to see that. But 2 times a year. Unfortunately, the lights of Phoenix you do get to see a little bit more often, but those are only visible to the camera. You don't see them with your eye. When you're out here in the desert, it's black everywhere you look. You don't see this glow. It's only visible to the cameras. And the building is on protected property. You can see some of the buildings on the property here. And so there's a lot of really cool stuff out here. That said, let's go back and look at our Measure 101 image and see how that's coming, because we've been stacking it and building up imagery. So it'll get better and better and better with more detail as time moves on.
Nick Faust, just look up.
Wow.
Go outside and look up. Meteors will appear anywhere in the sky. If you can trace them back toward the radiant point, not far from Arcturus, well, they're shower meteors.
Yeah, let me explain what Darrel's saying there. Okay, here's the Big Dipper we talked about before. There's the bowl of the Big Dipper. Okay, here's the handle of the Big Dipper. The handle actually points to Arcturus, that bright yellow star in the sky that you'll see. And between the end star of the Dipper and Arcturus, about a third of the way, right about here, this is the radiant. And when he says if you can trace them back to the radiant, meaning they're going to make a line back toward the radiant. So if you see one here and it goes zip, and you just see a little tiny streak right here, if it goes back to that radiant, it means that this is one of those meteors. Now, it doesn't have to be here to be this particular meteor shower meteor. It just has to be on the line connecting, you know, from this to wherever it is. If it's on that line, if it's pointing back toward that direction, then you have one of these shower meteors. Okay. And these are 15-second. These are 15-second shots.
Yes, Soviet Panda. New frame every 15 seconds. You make me feel special. Just look up. They can appear anywhere in the sky. if you can trace them back toward the radiant, as we were just talking about, they're a shower meteor.
I'm going to stop this right now. I'm going to go increase my exposure. Yes, I know. I stopped it, I thought. Oh. Fully stop. Okay, it's not stopping. Okay. It's still saving, so what I'm going to do is I'm going to stop the program and start it over again. Yep. Not going to hurt anything. Oh, look at that satellite came through our view there. Look at that galaxy. Oh my gosh, it's just beautiful. All right.
John, you saw a meteor. You did not see a meteorite. It's only a meteorite if it reaches the ground. If it's up in the sky, it's a meteor.
Just a technicality.
Yeah.
Okay.
If you see a meteorite, go grab it and pick it up, take it home. It's worth a lot of money. Did you lose the AllSky cam?
Yeah, something happened there. So I'm going to just see what's going on. Let me go back to this here. Oh, that's just great. Interesting. Well, that's just great. Our camera got lost. Last used camera info. So how did that happen? Well, I can't tell you.
Always something.
It's always something, isn't it? All right. Well, we'll come back to it in a bit. But first, I'm astonished by how beautiful this is. And actually, let's take this Measure 101 Galaxy and let's add a slight enhancement. Watch it get sharper right now. Look at that. Look how sharp it is now. Look at the spiral arms. They're just beautiful. This is just astonishing. This is among the best we've seen in the observatory. It really is. Among the best we've seen.
If you're talking about me, the other guy talking, it's my name is Darrel. I often hang out at the streams and participate with Marc.
Yep. Beautiful, my gosh.
I have
so, you know,
40
guys,
years experience.
You look at this beautiful sky, and this is the kind of thing you can get out of it. This beautiful galaxy. We can actually zoom in even further now, because this galaxy and this sensor support that. Look at that. All this detail in the galaxy. Now, as far as how far away we're looking, okay, let's just go on. Let me bring you in here, all right? Because I want you to see something, okay? The picture in the planetarium program is not as good as the one we just took. All right, but this galaxy is 20 million light years away. All right, 20 million light years away. That means that the light you're seeing that's hitting our camera right now live is 20 million years old. It left 20 million years ago from that galaxy. So you say, what was going on 20 million years ago on the Earth? You know, a lot was going on. You know, continents were still shifting. Dinosaurs had been dead for 40 million years. And but other creatures were filling those niches left behind by the dinosaurs. It's really quite astonishing. You know? There's an awful lot going on here. All right. Okay. Let's see if we can get the camera back here. Well, it's interesting that it lost our camera. Our AllSky camera got lost, but you know what? Our view, okay, when we look at the view here, our view is when they come out to the actual size of our camera view, all right? This is the size right here, watch. Pow. So there's our whole field, and this field is 4 full moons across and 3 full moons tall. There's a faint line right there. That's a satellite that came through at one point in the exposure. That's pretty cool. And we get a lot of satellites all night long, and they're usually the Starlink satellites. Okay, now I'm going to take this one notch down. Okay, all right, now I'm going to try and tease out a little more data. Let's see how much there is here. I'm going to drag this mid-level bar in, and it'll go really, really bright, but it's going to show us other data that might be there. And so we see that there's stuff out here. So we'll just process again and get that out here. This is a really, really pretty image. This came out really nice. And we've stacked 30 images so far and at this point. So I think that that's pretty good for M101.
Very nice picture.
Yeah, I think we should do the Whirlpool now.
Sure.
Taking advantage of a good night. And, you know, looking at it like this, you know, if there's a meteor that's going to come through, we're going to catch it. And actually having a meteor come through, this is a wide field scope, so we could probably get a meteor to pop through, and that's kind of where I'm going. All right, so we're going to save this, and up here you see the label. It says M101 Galaxy. That's how it's going to appear on our server, so you'll be able to see it. So we're going to save it now, and you'll see in this image here, it says it's a FITS file. That's an astronomical file format, but you don't even have to worry about that because I'm also going to save it just like you see it here and save exactly as seen. And now in the directory you'll see this image just like this with all its detail, and then you'll see the you'll see that FITS file. The FITS file is just a raw file, no processing done to it. This is a processed image that we did. So this is beautiful. I just want to take one more look at it before we move on. Let's go to 100%, and maybe we'll take an image look even deeper. Look at that. Now in galaxies, you see this dark dust. You notice it actually kind of looks brown. That's kind of what it really looks like because it's made of silicates and carbon. Okay, dust particles that are very, 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 very small. Did I say small? Okay, and then you'll notice that in the center the galaxies are more yellowish, and in the outside they're more blue. That's because in the spiral arms of these galaxies, like right here and like right around here and down this rim right here, this is where new stars are being formed, like in here. All right, look at that big, giant, gorgeous, hot, very, very hot star formation location, you know, and it winds around in here. Really, just a stunning image. It's just stunning, and we can literally go in till we can't go any further. Then it kind of gets blurry, a little bit, but you can see little details in here that get missed when you're farther out. And we can get rid of a lot of the noise in here. It's gonna really be something else. Hey Terry G, how you doing? So I think that what's cool is, everything we're doing is is happening right now. We're not, this is being added to as we spoke. I've saved it now. It'll be appearing on the server in just a few minutes. And what we can do now is literally get rid of it. That's right. It's going to be gone. And then we'll go back to our 1 second shot. And we'll come back to our hyper view. It gives us a view like this. So that's what it looks like in a telescope to the naked eye. You might see it a little better than that. Okay, but we're actually using a telescope that's actually got some power to it here. So now, given that that's where we are, let's go here and let's back out of this, and let's go to another galaxy that's gonna knock your socks off. If you like this one, you're gonna like this next one too. Some of the galaxies we look at are interacting with things, okay, and this galaxy is interacting. It's actually interacting with another whole galaxy, and it's literally right there, right near the tail of the Big Dipper, okay, the end of the handle, and we're going to go there. We're going to tell the telescope to go there right now. Right, so it's going to head there. It's already on its way, and it's probably going to use Alkaid as a waypoint star, I'm going to guess, and then from there it's going to go to here. Yeah, so it's coming in and it's going to center up Alkaid, and I'm at 61% on the sensor, meaning that I'm zoomed in 61%, but I don't have to be zoomed in 61%. Okay, I can zoom out here, so now we have 4 full moons across, 3 full moons tall. And once we're centered, all right, which is right there in the middle, okay, then we will get to this other beautiful object that's right there. Now, you talk about pretty objects. Okay, this guy right here, this is amazing. And I'm going to show you what that is. Okay. So, this, first of all, is a galaxy, and it's interacting with another galaxy. That little galaxy that you see up there, that's actually a galaxy. And this is a spiral galaxy. Now, you're going to say, why is it so small? I want to see it close. And you will, because I'm going to show you, really, in just a minute. So what we're going to do now is I'm going to zoom in on this, all right, and we're going to take a 35-second exposure of this, all right, and then we're going to take out our hypered view, because that's usually used just for finding, all right, so we're going to get rid of that right now, and then we're going to go into a live stack, and you'll see the previous one that's in the buffer, all right, and that's beautiful in its own. I love those spiral arms. And now compare this in this real-time view to this next one you're going to see momentarily, okay? So I'm going to clear this, all right, and then watch the next one that comes in. Okay, so here we go. There it is. That is the Whirlpool Galaxy, and the Whirlpool Galaxy is a beautiful galaxy, an interacting galaxy, and if we close in on it a little bit, you can see some amazing wisps of stuff coming off, and it's going to get even better. This noisiness you see, watch this next shot. All right, ready? Watch this now. Watch how it goes away. Okay, look at, see, much of that noise goes away. As you stack, the noise goes away because it's averaged away, you know. Hey there, Jeremy Willman, how are you?
Mark, pardon me a few minutes, please. I'm going outside.
All right, check it out. And Dr. Fox 2000 is with us. You know, if you guys like volcanoes and earth science, you got to go subscribe to Dr. Fox 2000. He is really good. I've you know, as an astronomer, okay, a professional astronomer, I know a lot about earth science, and when I go there, believe it or not, he says things that I don't even know. All right, he really has a good knowledge base, and he's doing it from the honest perspective of just being interested in the subject, and you know, you can't beat that. So you got to subscribe to Dr. Fox 2000 if you're here. I mean, and you should, because oh, for crying out loud, we've got how many people watching tonight right now? What are we up to right now? What are we at? We're at 1,600 people watching right now. And so I would say, please do subscribe to Dr. Fox 2000, you know, and learn some things about volcanoes. He's a really good guy. Hey there, Lucas Neely. How are you? And John G is with us here. And you make me feel special. I like that name. That's cool. And C&D Boy, thank you for putting that up. That was very kind of you, putting up Dr. Fox 2000's link. Thanks, man. Christo Paparopoulo, how are you? Creamers is here. Private's with us. Hey, we got a lot of people with us tonight. I'm really happy you guys showed up. I'm trying to get our AllSky cam back, but it looks like our AllSky cam has an issue. And it can't find the camera. I don't know why. So, I don't know what's going on. But we have a bunch of frames so far that we've captured. And you know what? You learn, over time, you learn that things happen. And it usually happens at all the wrong times. But one thing I can tell you is that our stream, when we look at galaxies, when we look at things that are in the night sky, you know, you're looking at things that are happening right now. That's live. That's a live image right now. That's live. This isn't faking you out, you know. And usually I'll come over and I'll say, now look, see this right here? This is the galaxy that's interacting with it right here. Okay, that guy right there. And then right there, this is the main body of the galaxy. But here's something interesting about this galaxy. These spiral arms were not there in the original history of this galaxy. But when it had this interaction with this galaxy, this one induced these spiral arms. Now, let's zoom in a little bit because I want to show you something here. All right, so let's pull you in right here. There we go. Oh, it's getting bigger. We've actually overexposed the galaxy. Our system is kind of good that way. Oh, easy there now. Go get away. There you go. It's also very hot. Okay, there's a lot of UV radiation coming out of these stars over here because these are all young hot stars that are being formed, and this is a huge bank on the spiral arms where these hot stars form. This is a beautiful bank of those. You see dark lines here. These are actually dark lanes that are stretched out dust and material from this galaxy. And let me put myself back over here where I'm safe in the corner, and let me pull this up again and show you something else. I'm going to modify this so you can see a little better. I'm going to darken up the background just a little. Okay. All right. And I'm going to soften the noise that we're seeing just a little. And then that's a little too much. Okay. Actually, I want to start from a point that it might use. So we're going to do this. I'll start from here. All right. So now I'm going to pull this over just a little bit. This is the peak of the data. This curve right here, that's the peak of the data. And this line here represents where dark begins. If I move this line over here, then almost all the galaxy is going to go away. Okay, except for the brightest spots. You put it just before the peak, and then you're going to get the most data without ending up with this kind of look, where it's all blown out. Okay, so this is right just before the peak, right at the peak here. This is about the best spot to be, just before the peak, where you catch the bulk of the data that's here. This is red, green, and blue data. Okay, then this guy, this is the levels, the mid-level of brightness. So the whites and some of the other colors. You move this down, and they're going to fade out. Okay, like that, leaving only the brightest nucleus left behind. Bring them back, and when they start intercepting that curve there, this curve right here, okay, varying amounts of data are preserved or removed. And so this gives me a chance to dynamically process the images for you right on the spot, so you can actually see what's going on in a way that is very helpful to understanding the object. Okay, but this is Measure 51. It's the Whirlpool Galaxy. I label everything, so if it's an open cluster, it's OC, and it's a cluster of stars are just loosely collected. If it's a globular cluster, a tight-knit group of stars, it's a GC. Okay, this is a GAL galaxy, and sometimes I'll put the type of the galaxy. So Darrel's out looking to see if he can see any meteors outside, and that's cool. Look at this. This is beautiful. Well, you know, our AllSky cam isn't working anymore, but I can tell you one thing. The telescope is working flawlessly. Yep, it sure is. My gosh. This is beautiful. And the telescope's auto-guiding as well, so I have parameters that I input into the telescope and make it actually guide pretty well. That's pretty cool. Hey there, Andre Schofield, Coffee, and Q Turtle. Q Tuttle, how you doing? Ashley Doll. Very cool. Many of you have never heard our streams before, so you don't know what the music is, but I usually have a bunch of different cuts of the music that I play throughout the streams. But one of the things that's interesting is that I have all new music now. And you don't know that because this is your first time, but so that's fine. But it's good to have new people here. And like I said, make sure you subscribe. We stream on almost every clear night out there in the desert. And it's only getting better because there's room in the building for at least one more telescope, possibly two. And we have one more telescope that we're going to put in there that's going to give us views that not just rival this one, but are superior. We have a wide field system right now, and the size of our sensor is such that when we look at this, okay, this is our full sensor view right here. And that it would take 4 full moons to fill this frame and 3 to fill this. Okay, so you can see that this galaxy is smaller than the full moon in the sky. Hey, Joe Letitia's here as well. He says, hey, Barona. Barona was a nickname that William Shatner used when he was in one of the Star Trek episodes. And that became my nickname. I was out on the golf course behind our bed and breakfast to check out the sky here in South Carolina shore, and lo and behold, the freaking sprinkler system came on. You know what? Only you, Joe. Only you. You know, but you know what? We thought up some pretty dastardly things. There was one guy in our astronomy club. I was the president of the astronomy club. And there was one guy in the astronomy club. I was a nerd, still am. And he had this really nice telescope, and we hatched this plan to make a fake telescope of his and throw it off the cliff in the middle of an observing session after moving his telescope away. We wanted to do it, but we never did get to do it. But that's the kind of stuff we did. I'll tell you another story. We're here on a meteor shower watch, and we are stacking. So this is a live view, and so if something comes through, we're gonna see it. But we actually had a 450-pound chunk of the Canyon Diablo, Arizona meteorite at my university when I was getting my degree in astronomy, and it weighed, as I said, 450 pounds. So one day, 4 of us had the bright idea, because the director of our observatory was actually giving us a hard time about our research and so forth. So we decided we're going to teach the guy a lesson. We all picked up this meteor and walked it into his office and put it on his chair. He comes in the morning, going to do some work, and there's this gigantic meteorite sitting on his chair. A solid iron chunk, 450 pounds, and my gosh, he blew up our phones when he called every one of us and said, "Who put that meteorite on my chair?" And I was like, I cannot tell a lie. Ron did it. And Ronald is like the one guy who didn't do it. So I mean, it was funny. We obviously came clean. And he did laugh once his chair was cleared of the meteorite. He did laugh.
Canyon Diablo?
Yes, Canyon Diablo, yeah.
I have a Canyon Diablo. It's about a little bit smaller than my fist.
Okay. Yeah, I have that Argentinian one behind me up on my shelf here in the office. But the Canyon Diablo chunk at this university, it was about 2.5 feet long by about 2 feet wide.
Wow.
Yeah, quite a chunk. Look at this, guys. Look at that, Darrel. The Whirlpool. Look at these stunning, beautiful brown wisps, these dark lanes in the galaxy that are drawn out by this interaction here. Look at this extra stuff out here. And what you don't see, guys, what you don't see is that this galaxy, this parent galaxy right here, all right, and I'm gonna actually let's pull this over and make this a full screen for now. Okay, this full-size view right here, this circular thing right here, this part of the galaxy, it's not just a flat galaxy. This one's actually warped downward at this point. This part of the arm is being pulled toward this galaxy, which is kind of below it. And so in reality, it looks like this to us, right? But it really looks like this if you look at it in space. It's warped, okay? But from the top, it looks like it's just flat, but it's really warped, okay? So the universe is in 3D. So that's what we notice, you know? That's what we notice. If you have any questions, feel free to ask in the chat here. You know, this is beautiful. Okay, we've stacked 25 of these, and we can see a huge amount of additional wispiness out here. Again, these galaxies have probably gone around each other several times already, and that's you know, what we're worried about here. We're trying to figure this out. Garrett Lutz asked the question earlier: when's the meteor shower happening? It's happening, but unfortunately, it doesn't seem to be producing, at least in our area right now. We had the AllSky camera running until it failed for whatever reason, and I keep trying to bring it up, and I try to find my cameras, and it says it can't find the camera. So something happened to the camera, but it's okay. What can I say? I've learned over the years not to be concerned about such things. You had something to say, Darrel?
Oh, I was clearing my throat, sorry.
Okay.
I mentioned in chat a couple minutes ago when I came back in that I saw one. It was east of the radiant, about 2 handspans. It was moving east. It was okay. It wasn't super duper meteor, but it was a meteor. And I assume from its direction of motion, it was moving from the radiant, that it was a shower meteor.
Okay. Izabela,
It's starting to cloud up outside, and it's getting cold.
Okay. Izabela says, there are many questions about your telescope system. Can you describe it, please, briefly? Oh, okay. I thank you, Izabela. I didn't see these questions come through. I apologize. Sure. What you see here is the telescope above me here. It's in the building. The building has a roof that rolls right off the building. I run it from Connecticut on the East Coast, and it's actually in the West, out in the Arizona desert near the West Coast. So it's 2,500 miles from here. And a telescope is a 10-inch instrument, and it actually is one that has a optical speed of f8 natively, but we converted it to f2. What does that mean? It means that the f8s are kind of slow, like with a camera. If you shoot a camera with the lens wide open, a lot of light can come in and hit the film right away, or the sensor. But if you don't have it stopped up like that, or stopped down like that, or open like that, and you stop it down to like f22, okay, well then the camera doesn't allow as much light in, and you got to expose longer to get something to appear. And this telescope originally came as a f8 system. Okay, that's the number. And we're running it now at f2. Okay, so we catch in 20 seconds what other telescopes have to capture in like a half hour. I mean, we literally are running 25 times faster than a regular f8 telescope. And that's really, really cool. Joe, I'd love to, he says, check out the Beehive cluster. I'd love to check out the Beehive, but it's not visible right now. It's very close, if not already set. That's in Cancer, and Cancer is, I think, gone already. And we can't look at it right now.
Yeah, if not gone, it's getting close to the western horizon. It's east of Leo. Leo's pretty far in the west now.
Yeah. Okay.
Just saw it when I was outside.
Okay. We stacked 32 of these of the Whirlpool. Look at that. Beautiful. Yeah. Okay, 32 is good. We're going to pause this. And we're going to save it. I have it labeled up there. Okay. And as we said before, this is the Whirlpool Galaxy. And it's called M51. Okay, that's this guy right here. Alright. And we will save it now. And when we save it, it's going to immediately leave our observatory building and head up to the server in the cloud. And this is the .fits, the FITS file. That's the astronomical format. Free readers are available online to look at that, but you don't need it because we're going to save it exactly as seen as well. And what you'll see now is a PNG file. When you see that, you just have to double click on it. You can bring it up in most applications on the computer. Okay. Crystal Brook says nothing here in Georgia except, and I missed that. It went by too fast.
Bats, lightning bugs, and the unknown sounds.
Oh yeah. Yeah, we got fireflies here now too. That's another issue when you take pictures. Sometimes you get fireflies and they look like meteors. Won't happen out here though. All right, so we did that, and now we can pause this. It's actually paused, and then we can get rid of this stack, and I'll get rid of the image in the buffer when we come back. All right. see, I never say die. I mean, I'm telling you, I'm pretty, you know, if the meteor shower / storm doesn't occur, doesn't mean we can't look at things and enjoy. And we have a big enough field, so if we see them, we might get something coming through. Ashley says, haven't seen anything in Arizona. Okay. Someone says, my neck is broke. That's probably from looking up, right?
34th
Yeah, so,
at Crenshaw. It was looking basically north. He was looking just to the south of the handle of the Big Dipper.
Okay. Let me get our computer back here. All right. Well, for those who've never been here before, you know, isn't this a cool experience? You come here, you got the most amazing people. You've got a great view. You got excellent equipment, and you actually can see things you've never seen before. And it just works like a charm. It's beautiful. So let's now go look at something else that you guys will love. We're gonna go to this. I've seen this. We saw this the other day. We're gonna see it again. This is called the Great Cluster in Hercules, and it's not a galaxy, but it's in our galaxy. It's actually called a halo object that goes around our galaxy, and it is a cluster of stars that's 25,000 light years away. So when we see this, you're going to see it as it was 25,000 years ago, because that's how long it took the light to get here from there. All right, so let's bring up our view here. We're at 100% on our sensor, meaning that we're zoomed in to the native size of the sensor, but we're gonna fill the screen with it, and we're gonna go to a particular star as a waypoint star, and it looks like that star is okay. It's gonna be one of the stars in the constellation Hercules right here. It's Eta Herculis. All right, and that star is being centered up right now. There it is. Okay, and we'll notice when we come back, when it gets centered up like this, when the cluster finally centers up, it's going to be inside that circle. And here it comes. And there it is. That's the beautiful Meteor 13 Globular Cluster. So like I said, if the Pleiades are below the horizon, sorry. If we're not going to get a chance to see meteors, well, guess what? We're going to have a chance to see some cool objects in the deep sky. I'm going to take you on a little ride, and I love it. All right. So now, this is Meteor 13, a globular cluster. Tens of thousands of old stars in this cluster. These stars are so old that they don't even have any of the elements in their atmospheres that make planets and other stars. Planets and other things that we see in other clusters. These stars basically have hydrogen and helium only in their atmospheres. They're very, very old stars. Back before the universe had suffered lots of supernovas where stars blew up and scattered their guts to the interstellar medium that made more elements to populate our periodic table. Okay, remember the periodic table? Yeah, we all hated that periodic table. Me, I'm a nerd. I loved it, you know. But see, I'm a nerd. I have glasses. See, I got my nerd glasses. I call them my Clark Kents. So, here at this point, what we're going to do is we're going to do we only need like 15 seconds. We'll do a 15-second shot here. And then we'll go into the stack. Clear the previous stack of the Whirlpool Nebula, Whirlpool Galaxy. Right? It's beautiful. But it's up there. It's up on the server probably already. And now we'll see this globular cluster. Check this out. Now that's a beautiful star cluster. Wow. Okay, and I'll add some processing to help it along. All right, here we go. And color's okay. I'm actually gonna take down the mid-range here just a little bit. And I'm actually going to pull this back a little bit just to kind of bring this all back a little. Now, if we zoom in, what we'll see is the cluster with all of its many stars. Now, these stars that you see all here, these are over here. These are closer to us. The cluster stars are way out here. All right, wow, way out here, and they're orbiting the galaxy. So you're seeing through these stars. You're seeing through the nearby stars, like this star. This star right here, that's a foreground star. Okay, this star's a foreground star. These are probably foreground stars. Look at the difference in the brightness of these stars. These stars are like a haze behind all of these stars. And that's kind of how that works. That's how that works, you know. So, that said, I'm going to now just take us down a notch. I'm going to just lower the brightness in the center so that Darrel can see his favorite element in this cluster. And there it is. This, by lowering the central brightness of the cluster, you can see this little odd appearance, this little thing here. See this little line? Right there? See this line? And then you see this line? Okay. Darrel's told everybody this before, and I've mentioned it. It's called a propeller. It's just a... It's not obviously a real propeller. It's just an odd-looking area that doesn't have stars in it. It's due to the random nature of the stars and how they're orbiting each other in this cluster. Just happens to have that kind of look to it. Pretty cool. Yep. Well, Vera, I've got my red lights on. I've got my purple lights on. I mean, this is my office, right? So I have my colored lights. We do a lot of television production here too, remember? So these colored lights are used when we go and do TV shows. This is neat. So this is Measure 13, and it's a globular cluster. Obviously, a globular cluster because it looks like a globular object. All right. So I put M13 GC up here. The propeller's pretty obvious there, Darrel. Look at that.
I see that.
Yeah.
You see that, folks? It's about 8 o'clock from the center of the cluster. It looks like a three-load propeller.
Yeah. Pato asked us to come in further. So yeah,
I'm sorry.
Right there. Pato asked if we could zoom in, so I'm doing it. There we go. Yeah, there it is right there. All right. And I'm going to try one other thing right now to try and just monkey with the brightness. Turn it down a little bit. I'm going to turn off our enhancement just for a second. Yeah. So by turning off the enhancement, you can actually resolve all the way to the center of the cluster. And there's that propeller. See that? There it is, right there. That's actually the nicest we've seen it, Darrel. Mm. It's really this is just a great, this is really just a great night. Hey, yeah. Grape Soda, thanks, man. I'm glad that you enjoy this. You know, I'm glad you guys enjoy it.
Conked out.
Yeah, well, I don't know what happened there. I'm going to have to find out. I mean, that's a pretty expensive camera, so for it to conk out like that is concerning. However, apparently we're not missing much. You know, apparently we're not missing much. Oh, thanks, Grape. Thanks a lot. Very cool. Izabela says, wow, this is the best image of M13. Yeah, Izabela, you're right. This is a really good image. Go ahead. I'm sorry, Darrel.
Ashley Dahl wants to hear more about Darrel and his background.
All right.
She said it, I didn't.
Well,
Ashley, I live in Colorado. I'm an amateur astronomer of over 40 years experience. I used to live up in the mountains. When I got my first telescope, I was living at over 10,000 feet. I had beautiful, clear, dark skies. That's where I cut my teeth. Yeah, you're right, Rascally. I live in Colorado Springs now, and I still do what I can.
and what he does is wonderful. By the way, if you guys are interested, if you want to hear more about this kind of stuff, every Sunday night from 6 to 8 p.m. Eastern Time, we have a 2-hour astronomy radio show on KGRA DB. It's on KGRA Radio, and it's sort of like a podcast, but we reach a lot of places. We're on Speaker, iHeart, and you can check us out there. And we've been growing our audience steadily. And I speak all over the world at conferences in astronomy and on UFOs, because I believe fully that extraterrestrial life is a foregone conclusion to me. That's why I wrote the book, The Populated Universe, which you can get on Amazon. But it really is my contention that the universe is basically full of life. Okay, life is the rule, not the exception to me, and it has to do with the nature of carbon in the universe. Now, I've said this before. Carbon is the 4th most abundant element in the universe. You know what's 3rd most abundant? Oxygen. 2nd, helium. 1st, hydrogen. So hydrogen, helium, oxygen, carbon. And carbon can mix and bond with almost every other element that it encounters. And those bonds can be broken and made in a fairly easy manner. And that's why it's so flexible for life, I saw Cruz mention, where are the meteors? Well, we'd like to know too. And we'd like to know too. We didn't see any. We saw a couple earlier, but the meteors have no longer either. It turned out to be maybe a bit of a bust. So you know what? We do a nice deep sky observation show for you as well. Joe Blow says, came for the meteor storm, stayed for the tour of the universe. That's cool. Well, hey, you know what? Again, we intended to show you all kinds of meteors. We were looking forward to it. But something happened to the camera, and as it turns out, people are seeing only a few meteors here and there. So if you look up, you're going to see a meteor. And especially now, it's 1:38 a.m. here in Connecticut. And I don't know how many other people like Bill Skywatcher saw. I don't know any other meteor streams, how many they saw. And seeing, okay, Mandy S, okay, I've seen 9 in 1.5 hours. Not a meteor storm. Kind of like a normal night. Because that's kind of what you might see. So, it is what it is. It is what it is. Anyway, that said, we have stacked 37 images of this. This cluster. We're actually we're at 105% here. To see the real size on our sensor and compare it to the moon, as we talked about before, let's check it out. Okay, this is the size on our sensor, and coming out to about here, it's just under the size of the full moon, just a little bit under. That's pretty good. That's pretty good. If you wonder why I'm looking left and right, this is my observatory feed, and this is my broadcast feed, where I'm actually seeing the chat and talking to all of you. Okay, so that's what's going on there. And I am out of focus. Hey, that's okay. All right. Look, I look like a little alien. I'm a little bald alien. Okay. Camera gets confused sometimes. It gets confused sometimes. Not a problem. All right. So, that said, I think that what I want to do now is take us to another object that might be interesting to see. Actually, Darrel, this is the latest that we've gone, so maybe I wonder if we've got anything from the summer sky that might be up yet. Like Ophiuchi, maybe.
Antares was well up in the southeast when I was outside earlier.
Yeah.
You're a little behind me, about half an hour, but
well, and Ophiuchi is above that. Okay, we're going to pause this now, and we're going to save Measure 13. This will make Izabela happy, because Izabela likes to process a lot of our images, you know. All right, and now we'll save it exactly as seen. All right. Okay, and now we'll clear this and get rid of the stack. Come down to 1 second here. Go into our Finder mode, our enhanced view. There we go. This is a live 1 second image, okay? So if something comes through, it's going to go leaving a 1 second streak. We see that all the time. Okay. Alright, where do you want to go now? Let's find out. Bring up my... Let's go down and... It's showing promise.
Try M57?
Oh, maybe. It's 40 degrees up, and I'm guessing that's in the northeast right now. Yeah. Wow, hey, that might work.
Sure.
Yeah. Alright, let's just try that. Now, I also want to come over here. Yeah, we got a lot going on there. There's Antares. Okay, you know what? Hey, thanks, that Gen X dude. Yeah, we are very tiny in the big picture, there's no doubt. Okay. Alright, here's what we're going to do. We're going to try to go to look at a nebula that is of a star that has died. Right? And this star is in the constellation of Lyra. Now, I know for a fact that the position of it is incorrect in the database. So we're going to see if it can find it. If it can't, I'll steer to it. It's okay. I can go manually. Alright. So you look at the telescope, you'll notice it's going way over because it's in the northeast. And it's going to find the waypoint star first. And when it gets to this location in the sky, you'll notice that we've got a lot more stars here. Right? That's because we're entering the summer Milky Way by heading in this direction. And let's find out from where we were, and this looks like, is this Sulafat? Yeah, it's going to be either Sulafat or the other star that's down there. Let's see here. There we go. Well, I guess it might have worked. It did. Look at that. This little guy is called the Ring Nebula. And we can zoom in on this because I want to show you this. Oh, von Neumann probes, OG Skywatch says. Yeah, von Neumann probes were a theoretical spacecraft that we might expect to see from an alien civilization because they might have actually just sent probes out all over the universe. And they were called von Neumann probes. Now, that was the thought anyway. And it's possible. You know, it's a possibility.
They were, what they call them on Stargate? Replicants?
No, is that what that was?
Well, the von Neumann's probes, they, you know, they spread out, they build more of themselves and
yeah,
send them out into space.
Yeah.
Self-replicating probes, as fantasy says.
I thought they were called the Goa'uld.
Oh, these were the little on Stargate. They were the little mechanical things that came scrolling across the floor.
Okay. All right, we're going to get an image here, and I'm only doing 12 seconds because this is actually a bright little nebula. And so
Cogs, the telescope is in Arizona. Marc is based in Connecticut. He's operating the observatory remotely.
Yeah, I'm in Connecticut operating the scope. I just put it all on the screen because this is a convenient way to handle the broadcast. Okay, so we're stacking this. This is an interesting thing. When you look at a star that has died, what's really going on is the star could have exploded in a supernova, or the star could have literally puffed up into a red giant after it used up all its hydrogen, converted to helium using the fusion process, right? And then it finds other things to make because it expands bigger, because as the star contracts, once it stops using hydrogen, more material, more elements that are in the outside of the star's envelope that don't enter fusion, because only the core is fusing. All the rest of the stuff is just there for the ride. Okay, but as a star contracts a little bit, once it stops using as much hydrogen, then other fuels make it into the core, and those can be fused. So maybe helium starts fusing into carbon, okay, and then the star will puff out into a big red giant, okay, because there's going to have some hydrogen fusion going into helium and then some helium fusion going into carbon, and so that overwhelms the star. It gets bigger, and then it runs out, and it keeps running out of material, and it pulsates sometimes, and every time it pulsates, it puffs off an outer layer. It puffs off an outer layer, and more and more, and what it leaves is this nebula behind. But in the middle of the nebula, right in the middle of this nebula, is a tiny little white dwarf the size of our planet Earth. And that white dwarf is something that can be visible. Right now, we can just barely see it here, and we have to understand that this is actually in the murk. It's very, very low to the horizon, relatively speaking, for us right now, and it's in the murk in the northeast area. And so what we can do is we can actually try to do some processing to assist here. Let me do this. Let me just do this processing. Okay. I'm going to pull this down drastically. Okay, and you'll see that this object looks like a donut. Now, the reason I think it looks like a donut has to do with the fact that no matter where you look at it from, it's going to look kind of like a donut. And that's because you have, if you look at my hands, okay, it's a shell of material coming off, while the edges have thick material. You can't see through my hands here. But on the front and on the back, you can see through my fingers. You're seeing through less, but as it comes around the sides, look, you can't see through my fingers at a certain point, and then you can see again. So on those sides, as relative to you, look thicker, and thus they look like a donut everywhere you look at it from. And we only did a 12-second exposure. If we do a longer one, we'll see that central star. But this is Measure 57, and I'm not going to save this version of it. Okay. And this is called the planetary nebula because at the time they were found, it looked like they could be mistaken for planets. All right. So, that said, let's now, I'm going to stop this stack, and I'm not going to save it. All right, but what I'm going to do is I'm going to do it again, but I'm going to make this a longer exposure. Now we're going to go to, say, 20 seconds. All right. And this might be enough to show that central star that's in there. All right. Let's go back to our stack. We're going to clear this stack. And now we're going to look at this again in this particular 20-second exposure. It's going to be brighter. Okay. And let's see. Again, it's still a little bit murky, but let's see what we can do here.
Surprised it's not showing up. It's usually pretty easy.
Yeah. I think it's it has to do with the length of the exposure.
Huh.
Yeah, and it's temperamental based on the fact that, I mean, you can just barely see it there. Okay. You can see it. It's not as obvious. I mean, we're at 231%. Okay, we're not even at our natural size. This is the natural size, 100%. Okay, but it's a smaller object, so when we actually look at it as it looks, okay, well, that's how big it is. Okay, again, in the 4 full moons across and 3 full moons tall field that we have in this telescope, the fact that we can zoom in that much is really quite spectacular. But there's other things we can find, and what I'd like to do is I want to see what else I can find while I'm here. If you notice where the telescope is pointing, it might be looking a little bit at the roof, and that could be causing some of the issues we're having. We have to wait for these to get to more, come up more. Oh yeah. What is that guy? Oh yes. Yep. I'm just looking for something in our planetarium view. Yeah. Yeah, and this I don't think that Scorpius and this part of the Milky Way is up high enough for us to see yet. So we're not going to be able to look at that. But that's okay. While we're here, I mean, they're just a little past the meridian now, but we could probably go look at some of these other galaxies that we wanted to see before. Like the Needle Galaxy. How about that?
Can't go wrong with that.
No. Now,
Wendy, we're heading back toward the direction of Virgo. We're actually in Coma Berenices right now, just north of Virgo. The galaxy Marc's about to show us.
Yeah, that's where I'm gonna go now. Yeah.
Yeah.
I'm gonna take us back down to a 1 second exposure, and then give us this enhanced view, and you'll see we're already in motion when we come back. And I'm also stacking, so I gotta get rid of that stack. Telescope is independent of that. It knows what to do. Okay. So maybe this is Vendemiatrix. Not sure. Okay, you can see the telescope is leaning now over that way and not looking toward the back of the building. By the way, looking that way in the building, that back of the building, that's toward the north. That way is toward the west. That way is toward the east, and this way is toward the south. Okay, coming out at you is toward the south. Okay. Here we come. We're zooming in. We're pulling in, and there it is. There's what? Well, this particular galaxy that we're looking at is a beautiful, stunning galaxy that has a central line of dust through the middle. And you know, we saw the Whirlpool Galaxy, that's face on. We saw M101, that was face on. We saw M100, that's almost face on. Now we're going to look at one that's on edge to us, okay? So now let's do that. Let's do a 35-second shot of this. Before I do that, though, I'm going to move things just a little bit. Now we're gonna move a little bit. I'm gonna move to the west a little bit. Center things up. There we go. Okay. And now I'm gonna just check my guider, and when the guider starts showing me guiding numbers, when it says it's not searching anymore, and starts showing us guiding numbers, then we know it's guiding, and we can do it. It takes about 11 to 12 seconds for that to happen. All right. Meanwhile, I got 35 seconds here. Okay, guiding has started. You can see the numbers. That's where it starts, and then it's going to start showing us differences. There we go. And now we can start the countdown and start the count, and we're going to do a 35-second acquisition of light, and it will be perfectly guiding. This is an accidental acquisition from earlier.
Marc, what's the somebody's asking about what's the power of the telescope. Have you ever figured out what your magnification is at your prime focus right now?
No, I haven't done that.
What's your focal length?
It's an f2 right now. It used to be an f8.
Yes. Let's see. It was f8, 10-inch f8, so 80-inch focal length.
It's like
200.
It has an f8. 250, maybe.
Oh, your focal length.
No, I know, but I'm talking about the magnification. That's what you're asking about.
Oh, well.
No,
golly.
Depends on the eyepiece you're using. Oh, at prime focus, though. Okay.
Yeah.
Yeah, okay. That's right. Yeah, I didn't do the prime focus. Okay. We started getting data here. Look at that beautiful galaxy. Wow. billions of life forms millions of years away. That's how I read this.
Like Lil King, no, not even close to that. He's working. It's a 10-inch f8 telescope, but it's working at f2, so it's 20-inch focal length, whatever that would work out to in millimeters. Let's see, 20, 250. You're 400 some odd millimeters focal length, aren't you?
Yeah, it's a 503.
Okay, yeah, 503. Oh golly, it's been so long since I fooled with cameras and stuff. You know, converting.
Satellite ran through here.
When I used to do astrophotography with my 8-inch, it was working at f10.
Yeah.
At prime focus, and I want to say magnification then was with 35 millimeter was 40 power, 50 power.
Yeah.
And I've forgotten all my photography. Anyway, Lil King, he's working at low power wide field. As he said, his field of view on his camera is about 4 moons wide by 3 moons high. And that's...
yeah, here's the field.
Yeah.
Satellite came through.
I would guess he's working somewhere around 20 power, maybe.
At F2, at F2, yeah.
Yeah.
Yeah. Oh yes, this. You know, I have to say, you know, this new music kind of fits. You know, this beautiful evening. I mean, it's hard to look at something like this and just say, "Oh, that's just a galaxy." It could be many civilizations we're looking at. You know, I'm one of the few astronomers that actually will tell you that I'm not just convinced, but I'm certain that there's other intelligent life out there as well. I'm certain of it. Why? Why do I think that? Honestly, I can tell you based on the carbon thing I told you about before, and on what we find when we look at the results from the Transiting Exoplanet Survey Satellite from Kepler and from the James Webb Space Telescope, soon to be. You know, when James Webb looks at an exoplanet atmosphere, you know, it can't see oxygen because it's looking only in the infrared, and oxygen is more in the visual spectrum, the visible spectrum. So how are we going to know? Well, when oxygen atoms collide with each other, they create byproducts, and those byproducts are in the infrared, and we'll see those. And based on how many of those collisional byproducts we see from colliding oxygen atoms, that's going to tell us how much oxygen is in an atmosphere. So we have the means right now, 1 million miles from the Earth, at Lagrange point 2, beyond the moon, to detect life in other star systems. That's pretty heady stuff. You know, pretty heady stuff. We've stacked 9 images here. And like I said, we can't see meteors. Well, we're going to see galaxies. We're going to see nebulae. We're going to see whatever we can see, because the universe is awe aplenty, without a doubt. Hey, more Jello, how's it going? Haven't seen you for a while, Jello. And Jazz Sink says, yes, there could be no civilizations as well. Yes, and you know what? Seth Shostak said something interesting about that. He said, you know, if there was life out there, it would be unbelievable. But if there was no life out there, it would be a miracle. Think about that. So I think really it's pretty cool, you know?
You know, I forget who said it, but you know, the universe is so big and grand and so full of stuff. It'd be a shame if there was nobody out there to appreciate it.
Yeah. And that's just a philosophical thing based on our humanness, right? But from a scientific perspective, it's pretty clear that the universe has these templates. And I will tell you about them right now while we're doing this. Okay. I mentioned the carbon-based thing, all that. But here's another thing to keep in mind. We are bilaterally symmetric. We're the same on the left as we are on the right. Okay, fine. And what's that from? Probably from the way DNA replicates, the way DNA unzips and makes a complementary half, you know, over in a cell structure, you know, when the RNA comes in and zips up another half. Okay, that's fine, all right? But keep in mind that life on this planet, every single life form on Earth has DNA. Deoxyribonucleic acid, okay, made of the four basic, you know, guanine, thymine, cytosine, adenine, the four basic amino acids, okay, and then we have other amino acids as well. But you know what's interesting about that? Every life form has that. Not only that, the Earth itself, way at the beginning of time, before there was life, it made those amino acids automatically with its normal processes. There was an experiment in the early 50s called the Miller-Urey experiment. And they had a flask and they filled it with what was a primordial atmosphere, thought to be, okay, carbon monoxide and water and other things. And then they hit it with lightning, meaning they had a spark gap and they just went ch-ch-ch. And after a week, right, they found that there were amino acids in the bottom of that flask. Now, what that means is that the Earth makes amino acids, the building blocks of life. It makes them by itself. And we notice with meteorites that have struck in the Arctic and Antarctic, where they were found in other locations, that amino acids came and were delivered by meteorites. Water was delivered by comets as well as manufactured here on the planet through volcanic eruptions. Okay, thank you, Vanessa. And I'll answer your question in a minute, Vanessa. And so the building blocks of life were delivered by asteroids, by meteorites, by comets, and by the Earth itself. It is as if, okay, hear me out, it is as if the universe has a template in place for carbon-based life. I'm not saying it's alive and all that. Some people argue it might be. But I'm saying that the universe automatically creates an environment suitable for life by the chemical slurry that it manufactures through exploding stars and the formation of planets. So the prevalence of life might be the reality and not the exception. Go ahead, Darrel, I'm sorry.
Well, I know every time we get into this line of thought, you know, what's the end result? Panspermia?
Panspermia. I mean, if you think about it, because the building blocks were made probably in asteroids and on comets, but with the Earth itself, how do we separate out and say, well, what was made only by the Earth and what was made by these comets hitting? We can't answer that question. So panspermia means life was brought here through other means. It didn't originate on the Earth. It was brought here through an impact with a comet, maybe that had some kind of amino acids on it. Well, guess what? All that's probably true. There's no one answer. Panspermia, yes, probably happened. Earth origin, yes, probably happened. Okay? Aliens delivered us. Probably not in the regard you might think. You know, our bodies have a huge reliance on sodium. Sodium, Na in the periodic table. Okay? Sodium is something that's really, really important to the biology of life. And we have a certain amount of sodium, not nearly as much as the ocean, but we have enough that says that we were made from the ocean. We were in the ocean at one point, and we came out of the ocean eventually. And that journey out of the ocean led us down the path of becoming land-based dwellers, and led us down the path of becoming hominids. And finally, Homo sapiens sapiens, which is what we are. Okay? But we look exactly the way we do, and we have this very fragile skin and fragile bodies, primarily because of 5 major extinction events that occurred here. So if we see alien life elsewhere, if they didn't have any extinction events, they might look very different from us. And we also noticed that in the Permian period, 252 million years ago, right, that was a time where the creatures that would become mammals were on the rise. And then there was a large-scale volcanic eruption in what is now the Siberian Traps, and that literally caused, in just a few short months, the temperature on the planet to rise by 21 degrees Celsius, because a lot of carbon dioxide got released into the air. Ecosystems died, plants died, phytoplankton died, and it was a chain reaction. 98% of all life on the planet perished during that time. Effectively, we could have been a dead world 252 million years ago. But life is tenacious. And as it turns out, life began anew. But this time, the things that would become mammals, that would become us, were relegated to the back seat, relegated to the darkness. And it became the age of the dinosaurs. And they ruled until they didn't, 65 million years ago, when another impact wiped them out. And those little guys that would become mammals rose from the shadows and became you. So, if you think about it, through a really circuitous path, we became the dominant life forms on the planet, right? And we can't expect alien life elsewhere to look like us. I think that bipedalism, walking upright with 2 feet, that is a template the universe provides. It's natural selection, it's evolution. And this is something that I think is prevalent throughout the universe. And I think other beings will do this and will have that capability. The bilateral symmetry, okay? The looking the same on the left as on the right. Bilateral symmetry is something that is very much on my mind as something that would be a foregone conclusion in the universe. There's no doubt. No doubt. So aliens might have 2 legs and 2 arms, 2 eyes, 2 nostrils. Okay? The way they interact with their world is through bilateral symmetry. You want to weigh in on that, Darrel?
Let's talk more monkey.
Let's talk more monkey.
Oh, did you answer the question about Oumuamua?
I'm letting you. I was going to let you say something, and you said that. So I can answer the question about Oumuamua. Vanessa asked if Oumuamua was a simple meteor. No, Oumuamua was an actual asteroid, but it was an asteroid that came from another star system. A true extraterrestrial asteroid visitor. Okay. Now, Avi Loeb wrote the book that talks about Oumuamua. Okay. And his book is a wonderful book that talks about the reasons why Oumuamua, on its way out of our solar system, moved in ways and acted like something that wasn't just an ordinary object on a ballistic trajectory as expected by something that's going around the sun from its gravity. It made odd movements. So, does that mean Oumuamua was an extraterrestrial vessel? No. However, it is interesting enough for us to say, could it have been? And all he said was, we can't deny that it might have been. We can't deny it. And he's right. I've worked with Avi a few times on productions and things, and I've spoken with his Galileo team, and these guys, they're no dummies. These are the smart people, right? So they don't have a penchant for going down these paths unless there's real evidence. So I would say get Avi Loeb's book and read it. That's a really cool book. All right. So we have 28 stacked now here, Darrel, of the Neo Galaxy. It looks pretty good, huh?
It does.
Yeah. Okay. liking that. Alright, let's see if we can change our colors a little bit. Get the space looking a little more proper. Gosh, that's a beautiful galaxy. Let's darken up space a little bit now. Gonna move this dark level over to just the beginning of our peak. There we go. Wow. That is so nice. So nice.
Let's do one more object. I'm going to have to go pretty soon.
All right. All right, let me, we've got 30 stacked here. This is perfect. So we'll pause this here. And I got Needle Galaxy up there. We're going to save it. All right, there you go. And then I'm going to save our object exactly as seen. And we have our ping file up there now. And that gives us... There we go. Okay, so now we can clear the stack. All right, Darrel, since you are gonna need to go, I will give you last call. What would you like to see?
Oh, golly, I don't know. If we were headed back toward Virgo, let's show them something good in Virgo.
All right, what would you like to show them?
Markarian's chain.
Okay, that's close by. By the way, this galaxy we just saw is also known as the Flying Saucer Galaxy. Now, I don't know if that's just a name that the planetarium program Stellarium uses, but it's hilarious. The Flying Saucer Galaxy. All right. All right. So let me. Actually, you know what I can do? I'm gonna do this like this.
Ashley, have we offended you? Well, she's gone now.
Why? What did she say?
I'm not sure.
Could one of you just let me know what Ashley said that was such a problem? She didn't seem like a problem. I'm not sure. Okay, Jello says Ashley's been hot and cold for the last 30 minutes. Okay. Okay. Let's now head to this other galaxy, Markarian's chain. And actually, it's not a galaxy; it's a bunch of them. All right. And
Mary Mayfield, I'm sorry, let me answer this.
yeah, go ahead.
What's the best telescope for beginners, reasonable price? That is not an easy question to answer. Depends on what you want to do with it. Depends on your budget. My usual answer is go to the Orion Telescopes catalog online. Either the 6-inch or the 8-inch Dobsonian made by Orion. The 8-inch will get you years down the road. Prices on all telescopes have been going up like crazy, just like everything else because of inflation nowadays.
Hey, you said you paid.
Yeah.
It's like double the cost now.
Oh yeah, just about. But the Orion 6-inch at a minimum, and the Orion 8-inch, if you can up your budget a little bit, the Orion 8-inch will get you years down the road.
Absolutely.
Eight-inch Dobsonian telescope, it's called.
Yeah. Okay, as you notice in the screen here, there's a lot of little fuzzy points, and these are all vast, huge galaxies. Outstanding. This is called Markarian's chain, and we're guiding now. So I'm gonna do an exposure here. We're gonna do we'll just do 25 seconds because that's really all we need here. And then we'll get rid of our hybrid finder view here and go into our stack. And so in our stack now, you'll see this come in just a few seconds. It's amazing, with this telescope, the way we have it set up, with the sight, with the capabilities, we literally can see things in a fraction of the time. Look at that. Look at this. There's galaxy, 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 galaxy. Boom, boom. We could probably count 10, 12 galaxies in this one image right here.
Oh,
maybe more.
More than that.
Yeah.
M87 is just out of field to the left, isn't it?
It's right over here. Yeah.
Yeah. You're looking into the heart of the Virgo cluster of galaxies here, folks. Mm-hmm. There are hundreds and hundreds of galaxies in this area.
Yeah.
This is the direction we're moving in. This is the direction that our galaxy and all the other galaxies in our local group are moving toward, is the Virgo cluster.
That's right.
It's like the densest concentration of galaxies in our part of the universe.
Yep. Amazing. And we're stacking right now, so we're actually adding up all the data and all the imagery, and we're going to be able to see some beautiful stuff here shortly. Not that we don't now, because we certainly do. All right. Let's start zooming in a little bit. Move this over.
The two close together.
These two, the eyes.
Yeah, those are the eyes.
And this is the I forget which ones those are. I can look it up, I guess. Remember, guys, if it's your first time here, please do subscribe. I thought you were going to say something, Darrel. Sorry.
I'm sorry, I was giggling. Ashley wants a Darrel channel.
Well, you should give her one. Why was she timed out?
I didn't do it.
No, I know you didn't.
Somebody objected to something she said.
Oh, okay.
Thank you, Ashley. That's a nice thought. I've thought about it. It's a capital expenditure that I'm not really willing to put up with. I'm retired. I'm on a fixed income, and I would probably just bore you to death if I had my own channel.
Hey, listen. There is a channel that I subscribe to, and all it is this lady who sits there and talks about her cats and everything else. And Keith from P&K Space Imaging and we each sent her $25 because this woman was a gem on YouTube. She was just a gem. Her channel is Crazy Cat Lady, and I gotta say, we laughed and laughed and laughed because in her own way, this lady is so funny, and she's not trying to be. That's what makes it so funny. So we felt bad, and we sent her money because, you know, 25 a piece, you know. And she thanked us, which was really nice, you know. Yeah. Here, let's identify some of these galaxies so people know what we're looking at. So here in Virgo, we're actually pretty leaned over pretty good here. So Markarian's chain is this, okay, this galaxy here is Measure 86. That's the bright galaxy that's right next to these here. These, let me, we got this one here. This galaxy is Measure 84. This is Measure 86. And these two galaxies have their independent names, okay, but they're called the Eyes because they just have that look. All right. They have this NGC number, New General Catalog number, 4435, and 4438. So this is 4435. This is 4438. Right, and then we have more up here. So again, here are the two bright ones. You got these others here, which are really interesting. They look like little UFOs, you know, but that's what happens when you see them kind of more edge on. They have that shape because it has a bright nucleus and then the disk. Okay, you don't see the disk, but it looks like that pointy, those pointy extensions. We got two more over here. Just amazing. Wow. There we go.
Jazz, I'm retired. That's what I do.
Ken James, how's it going in northern Arizona? Are you up near Flag? We're south of Wickenburg, west of Phoenix, with the observatory. I'm actually in Connecticut, and Darrel's in Colorado, and near the Colorado Springs. Hey Melissa, how are you? No, we didn't see any more, Melissa. Our AllSky camera ended up having issues, but there weren't many being seen, so we actually just started looking at galaxies and things. I mean, and guess what? This is fun too. Look at all those galaxies. My gosh. You can't imagine how many. Look at there's more down here. Look at all these galaxies. Every fuzzy object is a galaxy. Every fuzzy object. So you can imagine how much life is in this image. Izabela, you're funny. Oh yeah, actually Deb B says like a face in the middle. Yeah, look. Here's the two eyes and the mouth, right? And the nose.
Yep.
And a little tiny Charlie Chaplin hat on top. That's very cool. Yet these are called the eyes. I don't know why. Don't know why.
Isn't there a Einstein ring or something that they call the happy face?
Oh, that's a good question.
I seem to remember seeing that.
The happy face. I seem to remember seeing that too. Wow. Ooh, yes, it's Stewie from Family Guy. Get out of my way, fat man. I say, Brian. I like Stewie.
Sunshine, these galaxies are, oh golly,
Well, we'll find out right now.
M87 is 50 some odd billion light years away, isn't it?
Yeah, it is 55 million.
Yeah.
And then the brightest ones we're looking at here in Markarian's chain are about 51 million light years away and 60 million light years away. The eyes up here, okay, these two are going to be a little closer. They're 47 million light years away, and they're probably interacting with each other, so they're probably close. And well, this one says it's 66 million light years away, so they may not be close to each other. But then further up the chain, right, this galaxy here is 54 million light years away. The one next to it, which is actually an active galaxy, has all kinds of weird things going on in there. That is 89 million light years away. So they're at all these different distances. Either way, the light that left this galaxy 89 million light years away, this left that galaxy before the dinosaurs died. Isn't that crazy? And the light that left this galaxy here, 60 million light years away. That light left this galaxy only a couple million years after the dinosaurs died, if you think about it. So, however, I do this talk where I actually put the entire history of the Earth on a roll of toilet paper, and I go out into the audience, I unroll it, and what people find interesting about that is that for the whole 117 feet of toilet paper, the last 22 inches is the most interesting part, because 22 inches ago, dinosaurs died. All right, a quarter inch ago, Lucy, Australopithecus afarensis, was roaming the African Olduvai Gorge. And the rest of that time was the development of everything else, Cro-Magnon, Homo habilis, Homo sapiens sapiens, etc. Really interesting.
Mark, I'm going to bed.
All right.
Thank you for having me, and thanks for coming, everybody. I hope you enjoyed the show tonight. Come back if you liked what you saw tonight. Izabela, thank you. Grape Soda, Jazz, like Lil King, everybody. Good night. Y'all take care, and hope to see you again sometime soon.
Yeah, I'm sure they'll be back. Enjoy their company. They're good people.
Okay. Well,
all right, Darrel.
I'm going to go hit the hay.
All right, man.
Thanks again, and
Sure.
have a good night, Mark. Keep it up, I guess.
Yeah.
Good night, everybody.
We'll do our best. Thanks, Darrel. We'll see you later.
Uh-huh.
All right, bye-bye.
Good night.
Okay. Well, that was Darrel Mason, our favorite Colorado astronomer. We're having a good time. Let me just see here. Who asked that question about Alpha Centauri? Oh, Lake King 420 asks. Okay, yeah. Alpha Centauri is not visible from this location. We're not far enough south. However, I will let you in a little secret. We are actively looking for a southern hemisphere location. We're not made of money, but SkyTour Livestream, it's funded by those of us who love astronomy, and that's it. We don't have any official foundation support or anything like that at this point. We'd love it, but we don't have it. And it was founded by me with my desire to bring astronomy to people, because I noticed that too many people don't look up. They don't look up. So I choose to look up. I knew at age 9 I was going to be an astronomer. Age 9, and I never wavered. And my parents said, "Be a doctor, make real money." I'm like, "No, I want to learn astronomy." I think it's just a beautiful thing. I mean, how can you doubt this? Look at this beautiful chain here. Gorgeous galaxies. Well, we'll save this anyway because this is fun to have. We're going to call it Markarian's Chain. Alright. I probably spelled it wrong because the letters were kind of small. Yeah. Alright, so this is Markarian's Chain. Okay. And we have stacked 33 images, so we're good. This is more than enough. We're going to pause. We'll save the raw. There it is. And let's do a little color correct here. Let's gonna drop that down a little. And now we're gonna just not color correct, but just process a little bit more here. We're gonna darken our background. Beautiful. Now we'll save it exactly as we see it. All right. Wow. Well, guys, I'm going to take this time to say thank you for coming out and enjoying us tonight. If this was your first time, I hope you like it and I hope you come back. Okay? But it's time for us to hit the hay ourselves, and we're going to be back next clear night, which could be as soon as tomorrow. And we will see you then. And if you guys have any questions, feel free to leave them in a comment. But don't forget to like and subscribe, man. That's what helps us make our way. The more we get, the more we continue. I want to thank you guys that have donated tonight. I want to thank all of you who've been here for the first time. It's so nice to see you, and really enjoy hearing from where you're from. And so now, you guys have a good night, and we're not going to do any more tonight. We're going to close up, and when we do, I just want you to know that it's only temporarily that we're closing up. We'll be back the next clear night. So you guys, we'll see you later. Thank you for coming, and I hope to see you again on the next Sky Tour live stream. Good night, everybody.